we are all set for the session to unfold. And more importantly, I would request all of you to kindly come forward. The friends joining in late will sit back. So kindly come forward. We have the chair as well as the esteemed speaker ready. And in the interest of time, we are starting the session straight away. At the outset, it's indeed a matter of great privilege and pleasure to call upon the chair of this session, Professor Padmanabhan Govindarajan, Padma Bhushan, former director. Welcome to you, sir. And also, please put your hands together to Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India. The plenary talk, ladies and gentlemen, from Professor Ajay K. Sood will be about convergence. Kindly switch off the music, please. Convergence of technological revolution for advancing India's growth trajectory. And Professor Padmanabhan Govindarajan will chair this important session. So let's give a round of applause for the two esteemed personalities of our country. Hearty welcome, sir. In the interest of time, I would straight away hand over the session to our chair, Professor Padmanabhan Govindarajan, to take us through. Anyway, sir, you want to speak from there, you can. Yeah, come.
Professor Ajay Sood and distinguished colleagues in the audience, it's a great pleasure and privilege for me to chair this plenary session, which will be given by Professor Sood, Principal Scientific Advisor to the Prime Minister and the Cabinet Secretary. I have a small claim, the younger colleague at the Indian Institute of Science. Of course, we belong to different departments. An outstanding physicist, internationally recognized physicist. His areas listed as quantum materials, soft condensed matter, nanomaterials, nanotubes. I believe his perception of science is very broad. I remember we discussed years ago how his nanotubes can be used to detect malaria parasite. Professor Sood has obviously received several recognitions, difficult to catalog all of them. He got the Bhatnagar Prize. I hope this will come back in some form or the other. He's a fellow of the Royal Society, United Kingdom, which says is international recognition. He's an associate editor, he's an editor in several journals, associate editor in ACS Nano. The awards, lists are many, but I should mention IISc Alumni Award. I should mention the Bangalore government giving him Nano Award in 2010. So we have been extremely happy and proud that a scientist of his caliber, must be having something like 500 publications, 50 PhDs. I can give some numbers, approximate numbers, which only says he's a hardcore experimental scientist. And so we are extremely happy that he has been recognized and then elected as the Principal Scientific Advisor to the Prime Minister and the Cabinet Secretary. I have only two requests or plea to lay before him. The state of Karnataka, as you know, Dr. Sood, is most conducive for science and technology, and perhaps the largest number of startups. I'm associated with Biotech and some support is given to startups, but I do believe it would be very nice if you can initiate greater support to the startups, especially, everybody talks about valley of death when they take the next step. I think that's one plea. And the last plea I have is he represents the face of science to the government, and he represents the face of the government to us. Therefore, I believe he will protect the interests of the scientific community with all the technology revolution that is happening, whether it is artificial intelligence or 3D printing or synthetic biology or genome editing or big data analysis. I'm sure it needs a lot of support from the government. Of course, catalyzing probably private sector, which is coming forward more and more these days. And I'm only requesting him to protect the interests of scientists, and I'm pretty certain the government also, or the society also expects us to deliver, whether it is quality of science or whether it is translation. He has taken a most important topic today, convergence of technological revolution for advancing India's growth trajectory. Professor Sood, please.
Can I have a clicker?
This is forward, this is backward. This is one forward.
Which is forward?
This is forward, no? This is backward.
This is forward. Professor Padmanabhan, all the distinguished participants, intellectuals and innovators from all walks of life, and all the students who are present here. It is absolutely a delight for me to be here with you this afternoon and give this talk. In this talk, I thought I'll share some of the ideas, which is a very small subset of the technologies which are happening in the world and in India. So instead of cataloging all of them, I just thought I'll say where we stand with respect to the world in the country, in India, and what are the steps government of India is taking, and where do we expect to go. But before I do that, I would also like to acknowledge the role of government of Karnataka in promoting STI ecosystem here for a long period of time. I had the very close view of this when we were running Bangalore Nano for almost 12 years. And the support actually has grown with time. And a meeting of this nature, of this magnitude, of this scale, truly reflects the commitment of Karnataka government to science, technology, and innovation, along with all the stakeholders. So my congratulations to government of Karnataka, and I am sure as we go along, it will only increase. And whatever the orders Professor Padmanabhan has given to me, please be assured it is also my agenda. So I definitely have that, and it will be done. So let me start by again saying what I wish to talk on convergence of technological revolution for advancing India's growth trajectory. And what we are going to look at is a global transitioning towards knowledge-intense economies. So the question is how S&T contributes to economic progress, and how to increase in domestic technology intensity that will boost our global competitiveness. So these are the two goals which we will address in this the presentation. So this is a outline. Those who, because it's a after lunch session, so I'm giving you the outline before. You can choose where you want to snooze, and then you can come back. So I'll look at science and technology for socio-economic development and growth. India's ecosystem, a fact sheet. I'll give you some authentic data, commitment to our research and innovation, performance and output, and outcome and impact. And the third part, I will take few examples. As I said, this is a very personal choice because the office of PSA has been involved in one way or the other in shaping this or discussing this various ministries. And I will look at quantum frontiers, the fast growing frontier right now, advanced communication technologies, digital transformation, clean energy revolution, and One Health mission. And in the end, I'll discuss a few steps which our office has taken towards policies and the role of stakeholders. So this is what I said. We will look at global transitioning towards knowledge intense economies. And so I thought there couldn't be a better way but to look at two examples which have made a difference using the knowledge economy, a knowledge base to come to the stage where they are. I'll just look at Israel and I'll just look at South Korea. Roughly the time we got independence, they also got independence here and there few years. And what have they done by intensely devoting the energy, the input into R&D. So if you look at that, Israel is a leading performer in terms of its knowledge infrastructure, and now it ranks 21 out of Global Knowledge Index. As you know that the Global Knowledge Index emerged as a replacement to World Bank's well-known Knowledge Economy Index of 2012. So this index is more holistic and it incorporates multi-dimensional nature of knowledge and helps to guide policymakers and researchers in their efforts to foster knowledge-based societies and bridge knowledge gaps that will help to develop the society and economic growth. I don't know if you can see the numbers. It has various sectoral indices, which you may not see it, but you should see that their overall rank is 21 out of 138 countries, and their score is about 63.7 on the average. Extremely high, but the sectoral things, if you see, you will see that there are various components in this. You may not be able to read it. I'll just mention that research and development and innovation, they are third in the country, and they invest 4.65% of GDP on GERD. This is one of the highest in the world. And another one which we should take example from is South Korea. Korean Republic is a leading performer in terms of its knowledge infrastructure, and it ranks 19 out of 138 countries with a GKI score of 64.4. Again, remarkable rank, and the individual rank, well, sectoral indices I have given. But again, it all goes to show that they have invested 4.81% of GDP, and researchers in business enterprise is one of their strength, and GERD performances by business enterprise is one of the largest. Now let's look at India. India, we are at 0.7% of GDP, but here we have some areas of strength. So we rank 75 out of 138 countries in Global Knowledge Index. Our score is 44.4, slightly below the global average of 46.7. But our areas of strength is to create goods export, percentage of total trade in goods, and the number of graduates and the hopefully the quality in terms of science and technology, engineering and maths is very high, and it has a high ranking in scientific publication in terms of numbers. I'll give you some indices later on. This is where we need to work on. So this is individual development and growth, increase in domestic technology intensity, how it will boost our global competitiveness. That is our goal. So here I have written various indices. Again, maybe in a big hall you may not be able to see, but I just want to point out that in knowledge economy index, we have improved from 40.6 in 2020, and this is 2022 data. This has increased to 48 and improved from 27.3 in research development innovation index to 31. So these are the positive signs, but we need to work really much more. And other indices are more or less at the 2020 level. So let's look at the fact sheet. Here you will see I have plotted national R&D expenditure on the x-axis in absolute terms, and on the right side it is the percentage of GDP. So what is happening is the red line is the percent of GDP, even though R&D expenditure, which is shown by blue line, is increasing. That is because our GDP, fortunately and proudly for us, is increasing. The blue one, you can see that it is a huge growth in the last many years. Because of the constant, the increasing GDP, our GERD percentage is more or less same at 0.7, but this has to increase. And so here I'll show you the government sector contributes 58.7%, and the business sector, including all public sector undertaking, is about 41.3. So this is something which we need to see. How do we strike a better balance? It is good, but it can be better. So here you will see the central government is the major funder of R&D, 43.6, and the private sector is 36.8, and various state sector is 6.4, and so on. So this gives us a sense from where this R&D funding is happening in the country. And you can see that central government is the primary investor. This is an interesting table. I don't think I'll have time to look at all parameters, but just to take you along, and the matter of concern also, the second column, which is researchers per million inhabitants. Of course, we are touching 4.4 billion as of yesterday, as you saw the news, partly because of that, but partly because our numbers in full-time researchers are not that many. We are only 255 per million, that is 10 lakhs. Whereas in US, it is 4,200, UK is almost 4,300, China is 1225 with a similar population as ours. It is 1225, almost 5 times. South Korea is 7498, and I'm sure the South Korean delegation will be very delighted that they are sending a good message and a good benchmark. And Japan is 5,300. If you look at the PhD produced annually, we are producing about 40,000 PhDs, and we rank third. And the publication output, we are also third, but top 1% cited articles, our share is only 0.7%. This needs to improve. And the patents granted is a matter of concern. It is increasing, but it is only 26,000, and we rank 7th. So in a country like ours, where we need to increase the full-time equivalents, and the patents granted has to be looked at. This is the message from this slide. Again, I will not belabor this. I'll just move on. That annual PhD produced, as the projection says, in the STEM sector, which is the orange curve, by 2025, we will have about 40,000 PhDs. This is comparing with the US and China. Yellow curve is for China, and you can see that it has been increasing very, very rapidly. USA, I have put in two parts, US domestic and US total. When I say domestic means the people who are from the US origin, and you can see that it is increasing. India is the blue curve, which is increasing, as I said, but we really need to see the quality factor, and we really need to see how do we strengthen it. This is a good news story, but again, much more can be done. We have jumped in Global Innovation Index in 2022 to 40. So we were 81 7 years back, and now we are 40. It's a very good news, and we hope we can go forward in this evaluation. Again, this is a meeting with a lot of startups and lot of emphasis on that. I thought this slide might be of interest, that India has emerged as the third largest ecosystem for startups globally, with about 77,000 startups, which is a 15x increase in the total funding of startups, and 9x increase in the number of investors, and 7x increase in number of incubators. Also, in terms of unicorn, the estimate is that this aggregated valuation is about 535 billion as of this year. Here, what we need to focus in the next few years is the deep tech startups. There is nothing wrong in other startups, but deep tech startups are really the ones which make the country strong and independent. Here, number of deep tech startups, will increase. For example, it will be 3,000 by in next few years. It will have various factors which I have written. I will not go into detail. And cumulative funding raised will be about 2.65 billion for deep tech startup. I am differentiating between the 80,000 startups and the deep tech startups. This is again a projection, deep tech startup by 2025, at least 7,500 if it is normal, but if it is accelerated growth, sorry, it is the other way, 5,000 and 7,500 if everything is good. But all these charts are just to show you this is the aspiration which we should all have and work towards. So let me briefly touch upon in next 10 to 12 minutes, only give you a glimpse of this. It no means a very exhaustive study or a presentation, but many of it are discussed in this conference, and many of things will be probably discussed probably in the private domains. So I will just touch upon 5 revolutions which are happening: quantum frontier, advanced communication technologies, digital transformation, clean energy revolution, and One Health mission. In quantum frontiers, which is one of the very fastly growing quantum frontier, where we really need to work a lot, is that Indian government is very soon going to launch a quantum mission. It's almost done. Anytime soon it will be announced, and it has various ministries involved, and with a layout of almost close to 0.8 billion to 1 billion US dollars. And this is which will have 4 sectors: quantum computing, quantum communication, quantum materials and devices, and quantum sensing and metrology. So there will be 4 verticals in this quantum mission. So this is just to tell you, we are joining this whole league of nations which are investing very heavily in quantum frontiers. Well, I have just given the numbers. Again, I may not be able to read. United Kingdom, 1.36 billion US dollars. China is also of that order, which I have written. Canada is of that order. China is 10 billion, much, much more. And our Indian one is close to 1 billion over the next few years. So many people ask me, what is this quantum revolution? Because it is not really taught in colleges or schools. So I just thought I'll take 1 minute, which is absolutely, I'm not justifying this, but you should know that quantum revolution happened in 1913 when the spectral lines of hydrogen was explained. But that time, quantum mechanics was helping to understand the systems, atoms, molecules, and solids. You couldn't have your transistor, but for quantum mechanics. But what we are talking is the controlling the quantum states of atoms and molecules and solids. This is the big revolution which is happening, which has been only in the making in the last few years. And nothing more satisfying to see that this year's Nobel Prize is given in the quantum frontiers on entangled photons for quantum communication and quantum computing. So the prize was announced very recently. Now, just for, because this question has been asked to me so many times, I made this slide. What is the quantum doing? Just remember, in classical classical computers which you carry in your pockets, you have 0 state and 1 state. 0 state and 1 state. What happens in quantum mechanics? You can have simultaneously 0 state and 1 state. And that is a qubit. How much of each one is there will be decided on how you make a superposition. But that is the very crucial difference. And the big difference is you can have entanglement of these qubits, which is what I have shown in the cartoon. 0, 1, which is existing simultaneously, entangles with another qubit. So the entanglement of qubit is very critical to all these quantum technologies. Entanglement of qubits means properties are intertwined. If you know one, you know the other. And quantum bits, the bad news is they are fragile. Their coherence is lost. So you need to work on them. And this is where all the efforts are. There are many, many technologies in the development. It is not a final story. One of the leaders is the superconducting Josephson junctions, which is what is going ahead. But there are other technologies which are in the making, be it trapped ions, be it entangled photons, and so on. So this is what we need to do to handle this quantum this thing. So one idea which everyone is very excited is the quantum supremacy. Namely, this is the word coined by John Preskill. Can you do a problem which is only possible by quantum computers and not by classical computers? So quantum simulators, which is the dream of all of us, is to simulate the phenomena which classical computers cannot do. And it is now believed that the best thing is that wherever you have optimization issue, like in which are complex, which are exponentially in complexity, this is where quantum computer will come to your help. So what you have, for example, can we have a quantum model of photosynthetic molecule process which is so efficient, almost 90%? People are trying to duplicate that in the laboratory, not succeeded. So the idea is the quantum simulator can understand the pathways, which has not happened. If it happens, then you can do the rational drug design, you can do rational molecular synthesis, rational Haber-Smith Bosch process, whatnot. And recent paper this week in November 14th has said we have a long way to go. The reason is the noise in the quantum computer in this process keeps on increasing. And after 300 gates, it is overwhelmed by noise. So you have this noise generated from switching of gates that perform logic operation and in reading their output. So it's a big challenge for all of us. This is a problem which is not solved. So this is why I am mentioning it. Quantum computing is another area, communication, I'm sorry, where you need to have a secure communication. And what is the idea? Idea is that you send the signal classically, but your key is quantum, so that the key cannot be broken and you will have a safe communication. So that is why you have the quantum key distribution and there are various protocols. Good news is it is happening in our country at good pace, and but the challenge is quantum repeaters, because when you use entangled photons, you cannot go beyond 150 to 200 kilometers without amplifying. In that amplification, you cannot have the quantum key, and this is where all the work will happen in the next 2-3 years all over the world. Once we succeed, we'll have quantum teleportation and quantum internet. So good news is that with this Macan network, which also has the PSA office involvement, they have demonstrated up to 15 kilometers. And very recently, DRDO and IIT Delhi have demonstrated up to about 100 kilometers between Prayagraj and Vindhyachal. So this is a good news, but we need to go to those quantum repeaters if we want this dream to succeed. The next one is the advanced communication technologies. Many of you are more experts than me. I will only mention 6G. 5G is already rolled out and it's happening. But large number of technologies in 6G have to come because it has many advantages, including extreme coverage, low energy cost, and extensive massive connectivity and so on. So a lot of work has to go on. And the good news again is the Department of Telecommunication has formed a 6G Technology Innovation Group, which is looking at all the questions I have written here to make a roadmap to make so that 6G we are ready sooner than later. So it's already started all over the world. Something is happening here, but it has to be scaled up. Digital transformation is, you all aware, that it has many sectors. It has artificial intelligence and machine learning. It has cyber security. It has Internet of Things. It has cloud computing. It has big data analytics, digital twin, robotic automation, and enterprise resource planning. All this will be really the future of this digital transformation. And this is an area where India is taking a lead, and I hope it will take more lead than other nations. So I will again say that again a lot of opportunities have come. They are there in government sector. This is an old data of 2019. You can see the number of Aadhaar we have, the number of WhatsApp subscribers, the number of social media users in business sector and government sector. And this is all telling us, which is it does not need any intelligence, that digital opportunity is really a huge one for us to come in next few years. And I cannot but mention this metaverse. Metaverse is already started. We have the internet which is in 2D. Idea is you can have in 3D. You can have the digital twins of a city, digital twins of a factory, digital twins of a hospital, digital twins of anything. And you, as you know, that the first digital twin of Seoul was demonstrated not long back. And this is where lots of these technologies will be playing a role. So this metaverse is not only for gaming. Gaming is one aspect, but this is, of course, there are many things more. We will have interactive science labs using metaverse. You will have education and science more accessible. You will have virtual commerce, but also you will empower workforce and strategic capacity building. This is all that is possible and much more by metaverse. And this is what you should look forward in a very major way in the next 3 years. Clean energy revolution is already happening. We are aware of the CO2 rise and the surface temperature rising. And already there is the signals are on that we are not doing well. India has not been the major polluter. If you look at the overall thing, this is the debate going on in this week. But nevertheless, we have taken a conscious decision that we will limit our net zero by 2070. So this will have many sectors. This is only telling which sectors are contributing to CO2 emission. But here, there are many things which our leadership has announced to increase the non-fossil energy by 500 gigawatts by 2030, reduce total projected carbon emission by 1 billion tons by 2030, and net zero by 2030. So all this is not going to be easy. Please trust me. Many sectors have to work on it. And one of them, only saying one, there are many sectors, is the green hydrogen. So the green hydrogen looks at the good old electrolysis of water using renewable energy, not the fossil energy. Once you are doing that, then you can use green hydrogen in various applications. And biomass, which is a big thing for India, you can convert biomass to give you biogas. And yesterday I visited ISC lab, where we are mixing with steam. You can make the syngas, which increases how much hydrogen you can get out of 1 kilogram of biomass. And this is really the technology which will grow. Electrolysis, please remember, was made in 1888. It's not a new technology, but the optimization, the material issue, all are new, which has to happen. This is what the India expects by 2030. This is all the targets. I will not go because these are too many numbers, but it will have end use in mobility using hydrogen fuel cells. It will be feedstock for green ammonia in fertilizers, and it will also be used in steel industry for direct reduction of ores, and many more sectors. This is the whole thing is in the green hydrogen mission. As I said, this mission is about to be launched anytime. It is again a huge mission for the next few years, and India is committed to make green hydrogen as a major player in achieving net zero carbon. Battery is again a big factor in this, and this is where we need to go beyond lithium ion. You need to work on sodium, aluminum, and whatnot, and this is again a R&D area. Last one, I have so Padmanabhan, 3 minutes, 5 minutes, 5 minutes. I'll just give you one health mission, which is something which has been launched, not launched, which is in the preparation. So we have a PM STIKE. This is the Prime Minister's advisory body in Science, Technology and Innovation Advisory Council. In that, the decision was taken that One Health, which looks at holistic view of human health, animal, livestock and wildlife together, not in isolation. And this is the message all of us got very clearly in COVID time. You have to take all the three sectors in a holistic manner, and this is the mission being prepared now with the participation of almost 10 ministries. They are all doing One Health, but maybe there are gaps, maybe there are improvements needed, and this is what is done. And I'm glad that Dr. Sindhura is here. He is leading this mission to make it a reality. So these are various things I will not talk. Integrated disease surveillance. We will have the disease preparedness in terms of vaccine and diagnostics. We will have pandemic preparedness, all that with interministerial collaboration, coordination and communication. This is a big mission which we are launching, in which many ministries will be involved, many states will be involved. And you know that Karnataka government has already launched One Health mission, but this is something which will have to, this has, our mission document has many more factors, and this is what we want to do. It has many technology needs. Again, short of time, I will not tell you. You can read it. It has large number of technologies to be developed. What are the new platforms you need for all the three verticals: humans, livestock and wildlife? So what are we doing in the last 2 minutes? Sorry for not spending enough time. I will just tell you that in our PSA office, we have launched this National Science and Technology Cluster, and it is relevant because after my talk, there will be a brief ceremony or brief event to launch the Bangalore cluster. So we already have 5 clusters in Delhi, Hyderabad, Pune, Bhubaneswar and Jodhpur. And today, Bangalore will be launched. So this one has a pyramid structure. The pyramid structure is a very holistic. The bottom of the pyramid is where each cluster will enable the creation of a shared ecosystem with a large number of institutes in the neighborhood working together as one large institute through a formal umbrella but retaining their internal autonomy. Very, very important. Second, so it will entail sharing of facilities, sharing of courses, and so on. Second one, the pyramid is the becoming a regional solution provider. And here we will have these clusters will be the solution provider to local bodies, state governments and industries, and creating a regional influence. And of course, the top is national and globally competitive, at least in one area or 2 areas. These are just some snapshots of S&T clusters. I'll just rush through. Pune is focusing on areas which I have written. This is a reality in the last 3 years. And all these clusters, if you go to their website, have done extraordinarily well. Our office has given a very modest grant to catalyze the whole thing. But now they are going out and generating 10 times more resources than what we have given. And that's the success of the program. And this is where I hope Bangalore will exceed all the 5, because Bangalore is a hub of S&T and I. And if you cannot do it, I'm sorry, nobody else can do. So you have to take this challenge. We have a small ceremony. You will see who are the players. But this is where we need to do along with all the stakeholders. Hyderabad, Delhi, Jodhpur, I didn't have time, but the last part which I want to mention, this is what will be populated as we speak. And the last part, in last 1 minute, is a wonderful platform called Manthan. Manthan is a platform, it's a democratic and decentralized platform for collaboration between all stakeholders, between academia, startups and industry, as well as philanthropic and government sector. This is a very unique platform with many, many USP, which I will not read. And it has a very, very well-structured features. In that, we will have the demand side. Who will be the demand side? For example, industry and so on. What are the challenges they face? And our supply side will be the research institutes, incubators, startups, SMEs, clusters, and centers of excellence. This is absolutely fabulous, where you can put your problem and really have this very collaborative thing. So already the good news is that in the last few months, this was launched very recently, 3 months back, we already have total number of opportunities on the platform 45 in the last 2 months. Current open opportunities are 20, closed opportunities are 25, and success stories are already 7. And if you look at the projects which are going on, you can go to the website, please do that. And it has an international wing also. So international players will also be able to join this Manthan platform. With this, let me thank you once again for having me here and allowing me to share the vision of the PSA office along with all stakeholders. Please remember, PSA office is a catalyst. PSA role is to bring together all ministries, irrespective whether they are science ministries or not science ministries, do the policy interventions like in drone. The drone policy has a lot of things to do with our office. That's why it has gone to the level which we never expected. Many, many things are happening in the technology policy front. We have another arm which is called Empowered Technology Group, which I did not discuss, which also looks at all the futuristic technologies which India is working and India is procuring. So with this, let me thank you once again. Sir Padmanabhan, thank you for chairing this. and I'll be very happy offline interaction. Thank you.
But both of you stay here, sir, for the release we will have to prepare.
Thank you, Ajay, for such a, I should say, brilliant lecture, in terms of challenges, in terms of technologies. It was amazing, where sometimes I felt it's all dreamland, but looks, India is catching up. That is the good news, which whether it is quantum or whether it is digital, whether it is clean energy, whether it is One Health Mission. It's really amazing what, and I again want to repeat, we have the right man in the right office. I really hope, we are able to move forward. Dr. Sood has agreed to answer just very, very brief. Please don't give a lecture again. We can have 5 minutes probably. Anyone having comments? Chandrasekhara, you had something to say? Siemens? Yes. Make it very, very brief what you want to say. Mike, dear, Mike, could you?
Thank you. Sir, my name is Chandrasekhar. I have a question for you, Sood. During your presentation, you talked about innovation. So around 26,000 innovations are happening in India, but we are way back into the 7th level, right? So what is that one thing which we have to start from today to take it into the first level, right? So is this the educational revolution what we have to do, or the mindset what we have to change? What is that we have to start doing, and how do we make it a sustainable innovation, not the innovation which is destructive but rather constructive? Thank you, sir.
Hello. Yeah. I'll just okay.
There is no single pointer that it will, if you do this, it will happen. It has first the education sector. We have to change the way we look at the education. It is not just to get a degree. It is really to prepare us for the future. And that will not happen unless we really look at education as the major driver of innovation. So that, in my mind, will be most important. But other than that, we need policy interventions wherever it is required. In deep tech sectors, I do feel we need interventions, because otherwise our companies will start here and move overseas. We are aware of that. So we are looking at that. So as we prepare, we are preparing the policy document.
So my name is Vaidyanathan, Green Tech Entrepreneur. So quick question, sir. In slide number 43 that you presented on the challenges, buildings as a segment has been given a conventional projection. Slide number 43 of yours. Okay. Business as usual, our building requirement in terms of energy will be disruptive. Isn't there a need for newer technologies, material science, air conditioning, clean air?
No, I got it. This is on clean energy.
Yes.
Clean energy, I only touched upon green hydrogen.
Right.
Green hydrogen is one vertical which has opened up new hope, because we now, once the green hydrogen comes and once the hybrid vehicles are coming in the big way, mobility sector is already seeing the change.
Right.
You already have a hybrid with the bioethanol or biomethanol. This is, we need to now think in the direction which we have not been thinking. Green hydrogen is one. And I said, this is not all. Wind energy, we almost said India is not good, but that's not the correct. Can you innovate new ways to make compact wind tunnels, not the huge ones, which can be used? Answer, we don't know. Still work has to go on. So many sectors.
Right.
I'm saying clean energy, please remember, it will be something which will make or break us. We have no choice.
Yeah. Thank you, sir.
So I'm Colonel Kevin D'Souza. I'm a researcher from IDSA, New Delhi, in the defense sector. I just have one or two queries. One is that we keep speaking about investment of a percentage of GDP in research, basically putting money into it. And more money means more research output. But is that a fact? What about the other resources? We require competent scientists. We require the human capital. That's one. Second thing is, when we come to outcome of research activity or work, we look at number of papers or number of papers which are most cited, etc. But shouldn't we also be looking at how many of these scientific discoveries in India are actually materializing or getting commercialized
No, I understand.
into the final
No, in
outcome?
short, because of shortage time, I have understood even what you have not said. But let me just say that basic science, which you say publication, see, it is basic science or applied science is not the right division. It is good science or bad science. You would not have GPS in your pocket, but for the general theory of relativity. You could not do a money transfer without the geometric algebra. What is basic science today cannot be ruled out as the translational aspect. What is bad is the incremental science. And that has to, as I said in my talk also, though we are third rank in number of publications, I said very clearly myself that we really need to see how much is it really at the front end. And this is what we should work, not on numbers. We do not believe that numbers will help. Number of PhDs also will not help unless we improve the quality. Absolutely, you are on the dot. And there is a awareness, you know, even UGC has removed the restriction of the publications for PhD last week. So we don't need bad publication. Please don't publish bad.
I think time is really the culprit here, but is there anyone who's dying to make a comment? One final comment?
Hello, sir. Sorry to disturb you.
Yeah.
This is Professor Ranjit Raja from Tamil Nadu. I want to ask the one question. This is the last question. Sir, as an Indian government, we are not concentrate more on the underwater computing. Why, sir? Underwater computing.
Underwater.
Sir, it is underwater computing. Computing on underwater. We are having
Underwater computing.
Underwater computing.
I don't.
I am sorry, I am so ignorant in this hall. I
Okay.
don't know what you mean. You mean if a computer is dipped into water, whether work? Is
no,
that what
sir.
you're?
No, sir. Actually, we are
I don't
doing
know.
lot of network
No,
under
no,
the
I think we can do later offline because underwater computing, I don't know. But you know that India has launched a very, very big program, again started from the PM Strike mission as Deep Ocean Mission. You know that.
Yes, sir.
Deep Ocean Mission has all the aspects of deep ocean, whether it is taking the minerals out or whatever it is. So I am sure we can discuss with the experts regarding your question. Thank you.
Thank you, sir.
Thank you, Professor Ajay Kumar Sood, for a wonderful talk. And I would now request Shri Chris Gopalakrishnan, the chairman of Vision Group on IT, to kindly give a mementos to our chair and esteemed speaker. Thank you, Professor Sood, and also to Professor Padmanabhan.
Go fast.
present here, a very good afternoon to one and all. I am Deepti Murthy, privileged
Thank you,
to welcome you all
Professor
for the
Padmanabhan Govindrajan.
for the
Thank you, sir.
3-day conference of Bangalore Tech Summit. The first session for today is about Genomics Revolution 2.0 and its implications. May I please call upon Dr. Vijay Chandru, co-founder and director of Sciences. Please, sir. Sir has been an academician and turned entrepreneur. He has taught and conducted research in computational mathematics of optimization, geometry, and logic. Please, sir. Thank you.
Thank you. Perfect. Yeah. So I think we're right on time. Actually, I have a minute early. So, and since I guess, where's Ram Prasad? He's here. Good. So everybody's here. This is great. Maybe I'll just give some early remarks, and so that if the others are coming in, they don't miss out on, the Genomics 2.0 and its implications for certain reasons, right? Well, first of all, I just want to make it clear that you're in Bangalore and Bengaluru, and I think it's very appropriate for us to think of Bengaluru as the genome plateau of India, right? And some cities have genome valleys and so on, but we are the plateau, right? And I think today you'll understand why I say that. I think you'll hear also from success stories within Bangalore in the field. But let's take a step back, right? Why are we calling it Genomics 2.0, right? Well, first of all, let's think about how genomics has developed very quickly. Back in around 2010, 2011, I think Battelle did a study of the impact of genomics in the bioeconomy of the US. And they pointed out that the US had spent about 5.4 billion in investments in research at that point, right? I guess the Human Genome Project itself commanded about half of that, but there was a lot more of investment that went in. But the value of the bioeconomy from genomics was evaluated to be something like 780 billion at that point. So Obama made an address in the State of the Nation address. He pointed out that the country had reaped 141 times its investment in genomics, right? And today's, the theme of this conference, as you all know, has been around building the economy, right? And the whole inaugural session was focused on how technology drives the economy, and biotechnology and the bioeconomy in India is now stated to be around 80 to 90 billion. And the target is to get to about 300 billion by 2030, and we're talking about a 500 billion bioeconomy by about 2047. So those are kind of the targets, and I think one has to understand why this kind of acceleration has happened in the projections, and also in how this bioeconomy from genomics, from the source of genomics, has been driven. And back in 2004, I think, when Strand was already doing some work in the field of genomics and gene expression and so on, we had a board member called Bala Manian. And Bala, said, go meet my friend Jay Flatley, right? And so the next time I was in San Diego, and Ramesh and I, we were building all these products for gene expression, data analytics, and so Jay was interested in how we could adapt our platform for the bead array. Met Jay, and then a few years later, I suddenly saw in Forbes that there's a law named after him called the Flatley's Law, right? And Flatley's Law, just to give you a sense, is a lot like Moore's Law, right? Except it's running at the square of Moore's Law, roughly, right? So since about 2007, we've seen an extraordinary acceleration in genomic technology, and and thereby a reduction in costs, right? And of sequencing. And so, by and large, when you have these exponential technology laws, you reach a certain point where you get what you call singularities, right? And so what was believed was that when in computing, we got to the second half of the chessboard, that is, we got a multiplier of 2 times 2 times 2 times 2, 32 times, something happened, right? And that was around 2006, 2007, because the first semiconductors were developed around 1958, right? And according to Moore's law, you can work it out. The second half starts around 2006, 7. So the question is, when are we going to see that same magic happen with genomics? But I think we're very close. And so I think the whole idea of this panel is to think about, are we at a tipping point? How close are we? And what does that mean? Because, nobody could predict autonomous vehicles or, amazing things that have happened in electronics, the miniaturization in your smartphones or whatever, unless people were starting to think about what this exponential progress really means. So that's to set the tone of the session. I think may I now invite Dr. Joydeep Goswami from Illumina to come up. I'll introduce him while he comes up, and then he can give us the first presentation. So Dr. Joydeep Goswami is currently the Chief Strategy, please take a seat. Yeah, okay. He's the Chief Strategy and Corporate Development Officer at Illumina. And in this role, he's responsible for driving corporate strategy, pharma, CDX deals and licensing and OEM partnerships and M&A. But most recently, Joydeep also served as the president of Thermo Fisher Scientific's clinical next-gen sequencing and oncology business unit, where he oversaw efforts. Now, in addition to Thermo Fisher Scientific, he has led teams across various functions, including sales and marketing, R&D, and other support functions. He has also spent time at McKinsey, where he specialized in strategy for pharmaceutical medical technology and technology companies. He holds an MS and a PhD in chemical engineering and an MBA from MIT, and a bachelor's degree in chemical engineering from IIT. So, Joydeep, we look forward to your remarks on this 2.0.
Yeah, thank you. All right. Hopefully this comes through. Good afternoon, everybody. Vijay, thank you for the kind introduction. I am thrilled to be here, and again, to the organizers of the Bengaluru Tech Symposium 2022, thank you again for your kind invite. So I am really looking forward to sharing a little bit of our perspective on how genomics and bioinformatics is really changing how healthcare is delivered, but also provided to populations across the world. And there is a democratization of genomics that Vijay mentioned, which is really allowing countries and populations across the world to not only participate, but lead in the application of genomics to more personalized medicine, both from a diagnosis, prognosis, and treatment perspective. So let me walk you through some of this journey. A little bit about the company I work for, and that was Vijay talked about earlier as well. The company's name is Illumina. We are really privileged to lead the provision of genomics and through a technology called next-gen sequencing, or NGS, which really allows scientists to harness and explore the secrets and power of biology by unlocking the power of the genome, so DNA, RNA, but also now increasingly proteins. We spend about $900 million a year in our technologies and products, which really allows us to serve more than 9,000 customers in over 150 countries globally. Also through our clinical infrastructure and products, and in partnership with our global set of partners, clinical partners, we provide solutions, clinical solutions, to more than 1 billion covered lives across the globe. So I wanted to make a few points to you today. So first of all, the era of genomics is here, right? Very much so. The democratization and the reduction in cost of genomics, coupled with the ever increasing capacity that Vijay talked about, really are leading to a revolution of what is possible in the world of genomics and the application of these to science, biological science and discovery. Second, genomics has the power to reshape the entire field of drug discovery and development. But there are a few challenges there. First, to be able to handle data and manipulate it and draw insights from it at scale. But two, then to be able to provide a more diverse and genetically diverse set of populations to get to this very personalized phase of its development. Third, this diversity then provides a unique opportunity to countries such as India, both from a business point of view, but also from a human impact point of view. This genetic diversity is key to be able to really get personalized medicine that serves all populations rather than just a small part of the world. And then four, as I said, this is an inflection point for countries such as India to not only participate in this genomic revolution, but really to lead it. Sorry, the slides are... Okay, the slides are a little bit out of order here. Is that... Okay, there are a couple of slides missing here, but let me address them. This is actually important because, while we're all thinking about the genomic revolution being sometime in the future, few of us realize that it is already here and has been here through the COVID pandemic. So if you remember, the first indication of the COVID pandemic happened towards the end of 2019, where China reported to WHO there were these cases of unknown but severe pneumonia-like cases. Now, by Jan 9, 2020, Chinese scientists using our instruments had already sequenced the SARS-CoV-2 virus and had uploaded the sequences. And that then started off the race to find a cure. And that happened with companies such as Moderna and Biotech, later Pfizer-BioNTech, downloading the sequence and very quickly developing the first mRNA vaccines that were rushed into the clinic within 60 days of that first sequence being made available. Not only that, in about 9 months after that, we had our first mRNA COVID vaccines being approved by the FDA for broad dissemination across the globe. This is a phenomenal story because, this whole process unfolded without Pfizer, BioNTech, or Moderna ever touching the live virus, right? This was all based on the specific sequence that was, that was presented to them. Secondly, if you think about it, vaccines normally take about anywhere between 4 to 5 years or more to come to market, right? So to lessen that time to less than a year is a phenomenal achievement that would not have been possible without genomics really providing that data in the first place. And of course, technologies like mRNA vaccines being available. Now, this is a great start. And, I think what has happened since then is we have had a revolution where genomic surveillance is now available in a majority of countries, where you can now track the progression of the virus and the new variants that are popping up with the combination of these genomic surveillance technologies, but also newer technologies where you're sampling wastewater. So you can now understand community spread of disease, community emergence of new variants, and then very quickly use that information, that genomic information, to then develop new vaccines that are most appropriate, and of course, new control measures for pandemics. So of course, we cannot stop the next pandemic, but we can definitely be much better prepared and reduce the duration of those pandemics and the impact of those pandemics on us. Get the next slide, please. There we go. Thank you. So genomics allowed us to go from 0 vaccines, 0 mRNA vaccines, to more than 2.6 billion vaccines or doses of these mRNA vaccines to be distributed globally within a span of 2 years. This is really revolution that Vijay talked about in action. Not only that, we are seeing that an increasing number of rare diseases, more than 5,600 of these that affect more than 300 million people, being solved really with genomics data. So many of these are based on mutations in single genes, and coupled with the genomic information and newer technologies such as CRISPR, cell and gene therapies, oligonucleotide therapies, these are really changing the face of how we cure disease. So these already have about 50 such therapies on the market today, and more than 1,000 clinical trials that are addressing many of these diseases that haven't been solved really since the dawn of medicine. Not only that, we actually have a much better idea now of how to use genomics to solve the vast majority of other diseases that are not just based on single genes, but are on multiple genes at the same time. You can go to the next slide. So genomics really can transform patient healthcare management throughout their lifetime, right? Really transforming this life cycle management of the patient, but improving outcomes, and at the same time lowering costs. In the future, we believe that really the management of health will start with a genomic profiling right at birth, which then will provide a lot of information on the patient, not only to address some of the rare diseases that I talked about, but also a prognosis of when somebody might be more susceptible to certain diseases. Go on to early screening for diseases like cancer, which is really critical to reduce the mortality of these diseases through early intervention. And then, of course, progress through better diagnosis earlier in the disease, leading to better therapy selection. And then, of course, to effectiveness monitoring of the therapy and monitoring recurrence of the disease itself. Sequencing cost and sequencing timelines are no longer an issue anymore, right? We can sequence more than 128 genomes in under 48 hours at this point already. Next slide, please. So the other piece here is really around drug discovery and development. I had a long history here, as Vijay mentioned, but really the application of genomics in target discovery, so discovering new biological targets for drugs, can radically change the probability of success of any such molecules, right, through the drug discovery and development process, almost by 150% improvement, which then leads to almost a 50% reduction in these costs and a reduction in the time frame of drug discovery and development. Next slide, please. Not only this, human genomics really has the power to reshape drug discovery and development, right? Throughout the process. Now, some of the stats here are astounding, right? It takes almost $2 billion to get a drug from start to finish, at least with the FDA. $2 billion, of which about 60% of that is really attributable to failures of other drugs along the way. So you take the holistic cost, 60% of that is attributable to failures, which can be prevented through better information and better informatics. The number of new molecules that are approved by the FDA hasn't really changed in more than a decade, despite all the improvements that have been made in traditional pharmaceutical development. Worse, about 90% of drugs are only effective in about 50%, and max of 50% of the people that take them, right? So a vast majority of patients really do not benefit from drugs on the market. And, till date, very few of the more than 10,000 diseases that are out there are actually curable or addressable by any medications available on the market. Now, our hypothesis is that genomics and genomics-based discovery really can change the paradigm here. First of all, the availability of diverse genomic data sets representing populations around the world can really change the types of medicines that are available and address this issue of medicines only being effective in a small percentage of the population. Second, all this genomic data coupled with clinical data that is generated really needs to be addressed at scale. And the data through the development of new AI ML based tools can really be assessed much more effectively with much higher signal to noise ratios, leading to new insights in drug discovery and development. And finally, with these newer technologies such as CRISPR, cell and gene therapy, etc., really can address these diseases that have been so far considered to be undruggable. Next page, please. So let's talk about the two challenges that stand in the way of really applying genomics at scale, right? So the first one is really all about data. So the side effect of what Vijay mentioned about this Flatley's law really has come in just the last decade. The amount of genomic and multiomic information in just the pharmaceutical and biotech industry space, right, has gone up 50-fold. Last year, about 200 petabytes of information, genomic information, were generated on our instruments alone, just on Illumina instruments, right? And think about it, each human genome generates about 50 to 70 gigabytes of data. And within the next decade, we expect the number of genomes being sequenced to go up by an order of magnitude or two, right? So this is happening as we speak, and you can only imagine that the rate at which data is being generated is more than doubling every year, right? And it's only going to accelerate at this point. Therefore, it is imperative that the tools, both hardware and software tools, be developed to handle this data at scale and draw insights on this data at scale. And really, this era of big data in genomics and medicine is here upon us. Next slide, please. One more. Thank you. The second challenge is really the representation of truly the global population. So today, the big problem here is that genomics databases across the world do not represent the global population. And this leads to challenges because most diseases are brought about by mutations that are very specific to certain genetic ancestries. That means the problem that we face today of about 95 or greater than 95% of the data in genomics databases being only of European ancestry means that these genomic databases do not represent the vast majority of the world's population. To give you an example, Asians represent about 60% of the world's population and only represent about 3% or so of the data in genomic databases. This has some very real implications, right? First of all, I'll give you two examples here. Plavix, which is a very well-known drug to prevent stroke, in about 14% of Asians, the drug actually doesn't work. And another example is warfarin, right? Where, people of African descent who have a certain mutation in a CYP gene, they will actually not be able to tolerate the normal dose of warfarin that's given to people. It's a very important health issue. So getting to global diversity and global diverse representation of populations in genomic databases is really key to be able to develop personalized medicine that truly represents safe and effective drugs for a majority of the globe. Next page, please. Of course, there's hope here, right? There are several efforts, including many in India and in Africa, that are really addressing this issue of diversity. So there are many population genomics efforts going on, which I think will solve this issue or at least get a long way forward in the next decade or so. Next page, please. So we truly are at an inflection point for more countries and participation of more countries and to lead this genomics-driven revolution in health. And India, I feel, is particularly well positioned in this area. So by 2010, 7 of the 10 largest global economies will be ones that are considered emerging markets today. It's a really important point. Moreover, sequencing and genomics can address the overwhelming amount of disease burden that these countries will face. It is already surprising that about 70% of the global deaths due to cancer are from what are called low and middle income countries, right? Where you would expect infectious disease to be much more a cause of death. But these, cancer is already catching up because of greater, life expectancies of people, really catching up to be a key impact here. The good news, of course, one of the nice side effects of COVID-19 is that the world has woken up to the importance of genomics, right? And we expect that by 2032, all 194 of WHO member states will have the ability to surveil and track pandemic-related viruses or pandemic-related pathogens. Lastly, I will say that India is particularly well positioned to lead in this genomics revolution. We expect that the healthcare spend in India is going to increase by about 800% in this coming decade, really positioning it well to take advantage of advanced technologies such as genomics in driving the next wave of healthcare. So with that, I am very confident that many of you in this room will be critical to actually lead this next wave of healthcare revolution powered by genomics in India. Thank you very much for the opportunity, and I'll turn it over back to you, Chandru.
Yeah, let's get the panelists. Can you stay on and join the panel? And right, yeah, let's quickly invite all the panelists to come up. I think they're going to set up some chairs. Shall we just grab some chairs?
So may I please request the panelists to come up on the stage?
Sure. Yeah.
Navneet.
And we need some chairs.
It'll just take 2 minutes, sir, for the chairs.
Just grab
We should
chairs.
just drag these.
Yeah, I think there's no need to wait. Yeah. Thank you. That's quick, right? Yeah. So yeah, while all the formalities happen on setting up the name boards and so on, we have Dr. Ramesh Hariharan, Dr. Ramprasad, and Dr. Brotati Kali here on the panel. And as I was saying, hi there. So, we have a representation of why I'm calling Bangalore the genome plateau of India, right? Dr. Ramesh Hariharan leads Strand Life Sciences, which get each of them to speak about their organizations and their interests, of course. Dr. Ramprasad has been with MedGenome right from the outset and leads the India organization. And Dr. Bradati Kahali is with the Center for Brain Research and also at the Indian Institute of Science, and is deeply engaged in India's leading public genomics project called the India Genome Project. So, so these really represent the leadership in some ways of genomics. There are also, of course, a lot of other players in genomics in this city and in other cities, but you know, we can't have all of them on stage, so so we've picked a few. But now what I'll do is perhaps again, given this context of discussing 2.0, the tipping point, the potential that Joydeep so nicely laid out of for both India and the globe in genomics. I think I'll let each of the panelists speak for a few minutes, maybe 4 or 5 minutes, and then we can open it up for discussion. Yeah. So yeah. Ramesh, maybe you can use the podium. Yeah. Okay.
Thank you very much. Good to see you all here. Quick introduction to Strand. So I and Chandru co-founded Strand 22 years ago. I mean, those were the early days of infancy as far as the Indian startup ecosystem was concerned. And we were all computer scientists starting a company in genomics. And the reason we started the company was that we could see that genomics is going to be an eminently interdisciplinary world where the task of sequencing the DNA, the task of generating that data was only the first step, and that the real action thereafter would be to just make sense of what that data is about and how do we transform it to apply it to various scenarios, be it drug discovery, be it improving the health of an individual patient, etc. And that's the field that we call bioinformatics. How do you take the data and make sense out of it? And for the first decade or so, Strand worked as a bioinformatics company. We've worked with a lot of the global organizations across, helping them analyze their data, understand what that data means. And through that process, we were able to support the generation of, a lot of new knowledge that's captured in over 25,000 publications that used our data, tools, services in some form. Somewhere in the second decade, thanks to the efforts of companies like Joydeep's Illumina, costs of sequencing started going down, which meant that more and more sequencing could be done, more and more data could be generated. And some of this could be applied, therefore, not only in relatively esoteric research situations, but to definitely broader research situations, as well as, more importantly, to individual patients who are seeking solutions to their specific disease problems. So that journey of transforming genomics to a diagnostic in India was led by Strand and MedGenome. You'll hear from Ram as well next. And the initial applications were all in areas where we could make sense of the data relatively easily, what are called monogenic diseases, where the cause of the problem lies in a single place in the DNA. And that has become an industry. There's ongoing, it's growing, awareness will grow, a lot more people will sort of be able to use the benefits of that. And that brings us to today, where we have a next phase, Genomics 2.0, where there's a step change happening in the cost of data generation downwards, and therefore there's going to be an exponential explosion, I guess, in the amount of data that we can generate. Over the last 20 years, we've learned to make some sense of the data. We are still not great at it. We are able to do things, understand if things are sort of problematic at one place in the DNA, and that is able to impact health. Over the last 5 or so years, 7 years, our ability to tease out effects where things are very multigenic. There are 20, 100,000, 10,000 places in the genome which together collaborate to make an impact on health. We are starting to tease out those effects, but there's a long way to go in that. And that is only the beginning of the story, because the DNA, the genome that we are talking about, is what we inherit largely from our parents. There's a whole window to the DNA on what happens to it as we evolve in our lifetimes. Our DNA is not static, it changes. That change causes diseases of various kinds. Cancer is a hallmark of what is called a somatic change, a change in the DNA that happens over the course of your lifetime. So not only is sequencing your inherited DNA will become more and more accessible, but we are starting to get a window into applications which will look at how your DNA is evolving over your lifetime and be able to use it for health decisions. Classic example of that is that where do you access that DNA? The DNA is sitting deep inside your body. Cancer is caused by a single cell somewhere deep inside. How do you get hold of that cell? So through the blood, you have a window into all the cells inside the body and all of the information integrated into the blood that you can sequence. So now if you look at Genomics 2.0 and going forward, what opportunity does it hold? Number one is taking these so-called monogenic effects and just bringing them to a larger and larger number of Indians, making them accessible. Cost in India is always a consideration. A lot of effort, a lot of progress has been made in getting that cost down. Today, genomics is accessible to the layperson, to the patient in India at costs which are far, far below what they would be anywhere in the world. Is that something that we can continue to sort of evolve as newer and newer applications come in? I'm sure we can. And can we drive it further down? Those are areas of work that are key in the near future, but that's only one part. The second part is how do we start contribute to this whole revolution of these multigenic effects, where we have to tease out these very, very sort of complex interactions between many genes that together lead to disease. Most age-related diseases are of that type. And there it comes down to sequencing lots and lots of people. So how do we make genomics accessible enough so lots and lots of people can get sequenced? And a number of efforts are going on. We are announcing an effort today where we are releasing our what's called our genomic wellness line, which makes whole sort of sequencing all the genes accessible to any person who wants to do it, and there's a bunch of things that you can learn from that. And then, most importantly, as we go along, we are working on a number of different products that will allow you to monitor your evolving genome as you go through your life and see what it does as you age and how that can change and detect disease early. So this is exciting times in terms of genomics. We see a lot of new applications, a lot of new data, a lot of new insights. Every day I wake up, there's 30 papers in my feed. How do we keep up with this? That's our challenge today. So we'd like to invite all of you to join this effort and participate in it. Thank you.
Just for the benefit of young people in the audience, Ramesh has also written an extraordinary book called Genomic Quirks. It's published by the IISc Press. I would urge young people in the audience particularly to get access to the book. I guess there's an e-version that's on Amazon and available, so you don't even have to pay for it. But I think it's an exciting turning point in technology and a revolution that's going to happen, and it's important that young people are well educated about that. So that's a little plug for the book. But as Ramesh mentioned, this was a journey that both Strand and MedGenome were involved in, and I invite Ram to make a few remarks, please.
Thanks, Dr. Chandru, and everyone here, and thanks for coming down. It's a very interesting times for us in genomics and omics per se, because it's going to be an era of data biology, and it's going to grow more and more. And as you can see in the previous speaker, the kind of different applications deciphering the genomic data, what you get. About 15 years back, you never had imagined that just sequencing a small piece of gene or a genome will have so many applications. I just give you a small example. 2001, I was doing my PhD, and there was a patient family who was affected with what Ramesh has explained, a monogenic disease, a very rare form of eye disease. And we started working on that. It took about 8 or 10 months time, and with the help of some multi-institute collaborations abroad and everywhere, we identified after 1.5 years a gene which is called as RP65. Very few people know that this came from India, and it's from southern part of India. And we published this as a half-page report in Nature Genetics. It's called as RP65 gene, which causes a blinding gene. It was in 2001, and 2021, the first gene therapy drug, the whole world came for RP65 in US, and today the drug costs about $3 million for the treatment. That's a different story. But a small study done at one corner of the world, a drug coming from another part of the world, just using that information data, and it's coming from India, is something that it clearly shows that if at all this science has one of the major impacts in any part of the world, it's countries like India, where this will impact more than 1 billion lives. So it's very important, and we have all the resources, we have talent, we have skill set, we have now at least a favorable funding environment compared to 10 years back. We have educational institutions, and we have a decent atmosphere. I think it's the right time for us to plunge into any aspect of this omics, and it gives a lot of advantages and big investments for India, employment opportunities, and we have one of the biggest software talent in the world here, and it's all about data, how you get interpretations of data that comes out of it. The second part of it is one of the biggest challenge we faced when we started was Sam, who was the founder of MedGenome, he came and said, Ram, let's do a 23andMe India play. Okay, so 23andMe is an American company which gets testing done for sort of a wellness, or you can call sort of recreational genomics, and uses the data for various purposes, consented data. But when we looked at requirements, the huge unmet need that's there in India was not that part of it. Well, yes, there are a part of tiny fraction of population who are willing to learn about it, but majority was on the illness side. Okay, so we started visiting hundreds of clinicians virtually Monday to Sunday. We used to visit almost every clinician, every pediatrician, every oncologist name, just to understand it. Then we found, within 6 months, we found there is a significant need for this. And at that time, the utility and applications were also very small, not as how it is today. We never heard of liquid biopsies that day. We never heard of tumor sequencing that day. But we still felt there is a huge need for two reasons. One is whoever can afford, they were sending their test abroad. Second, the morbidity as well as the disease burden is very large. And we need cost-effective, low-cost tests in India, which can come down significantly, more than 50% of the costs that are borne in the western part of it. So that was our single mandate, where at least for the next 5 to 6 years, we are going to just keep focusing on illness side. And we focused on about 5 or 6 segments, starting from cancer, reproductive health care, rare diseases. It's not rare, the definition is rare. Today, every tertiary pediatrician sees about 4 to 5 cases a day in a clinic. So it's not rare. And of course, infectious diseases, as COVID was mentioned. So the impact is significant, not just in terms of business, in terms of the social impact. The impact you can have on lives is much far higher. And that is where we are seeing now, last few years, the new data tools. It could be machine learning, NLP, or AI. It's changing the game completely. It's all about wet labs are shrinking, dry labs are expanding. Today, the recruitments that we do are more on the data side, less on the lab side. I think it's going to change a lot. The more opportunities you give and the more competency is there on how you decipher the information on the data, I think there are much larger opportunities for us as a country, as Bangalore, which is the hub for software, data, and other aspects globally. I think we should seize this opportunity in every way and create more and more opportunities, impact on the lives. There are large number of patients who are seeking everyday solutions for their suffering and burden. I think it's a big impact. Thank you.
Right. Now, may I call on Bratati to give us sort of the public view of, from a public institutional perspective, the work in genomics.
Good afternoon, everyone. Thanks, Professor Chandru, for this invitation, and it's very nice to be here. So I'm Bratati. I'm from the Center for Brain Research at the Indian Institute of Science. And we did not intend to have a Genome India project, which is identifying the genetic variations in our population as a first objective. What we were trying is that we have other studies ongoing at our institute where we try to understand the genetic risk and protective factors towards neurodegeneration that could lead to neurodegeneration in our population. Now, soon when we started to do the genetic analysis, we figured that the arrays that are available and perfectly fine for the European population or some other admixed populations are unfortunately only about 50% informative for the Indian population. So what was the way out of that? So we need to build a reference for our own. And that is why, as our keynote speaker has also mentioned, is that the locations where we differ from one individual to another individual is different across populations. And we need to identify those positions in more and more genomes of our Indian individuals. So that is how sort of Genome India was born. And slowly it turned out as a hugely collaborative effort across the country. And we have about 19-20 institutions as part of this project, funded by the Department of Biotechnology, Government of India. And we intend to identify the genetic variations in at least 10,000 individuals across the country, spread across the country. So it has a huge impact because once complete, we will be able to tell the population-specific variants, which in the beginning that we were looking for in order to understand the disease susceptibilities better. Because depending on locations of the genome, our disease susceptibilities would differ and even their extent could differ. And if there is a difference in that, the interactions of those locations with the environmental factors would also be different. So it was extremely pertinent that we keep following this, and we can have a huge impact in the sense that we will have a population-specific genetic variation panel available. We will be able to, let's say, from the pharmacogenomic perspective, we will be able to say, if we see certain variations in the drug metabolizing enzymes in certain population groups, that is an extremely important information for the clinicians and takes us a step closer to the precision medicine approach, because that will be extremely important for which drugs could be effective, which could be not. There could be certain variations in immunologically important genes. I mean, we have recently seen the importance in COVID, right? I mean, the sequence was available, the mRNA vaccine was developed from two of the hits that initially scientists had. So technically, then these kinds of information for our own population would be extremely helpful. Now, revolution in the sense is that there is an extreme data revolution, of course, not just in the way that we generate terabytes and terabytes of data, but just to analyze less than 100 genomes. Although we have reduced on the time scale because we have huge HPC infrastructures, or even nowadays black box programs are available, not exactly recommended for students, but very good for solving the time situation. So there, what we see is that in intermediate analytical stages, the data blows up to like hundreds and hundreds of terabytes. So we really see a great opportunity for understanding those perspectives as well from the computation side. Now, with the different kinds of sequencing technologies available, we are at a situation where we can understand not only that the variations that are there in single positions as well as for entirely large stretches of the genomes. They can be even spanning more than 50 bases. I'm assuming a whole lot of audience already know what are bases here. So these are the things where we can understand the disease susceptibilities of each and every individual and bring ourselves closer to precision medicine. And I'm seriously hopeful that from the sequencing from our cohort studies and from Genome India and the other studies that we are involved in, for example, we are also partnering with the Broad Institute on a bipolar genetics project in order to find the susceptibilities for the disease in the South Asian, and our team is taking care of the Indian arm for that. So all these things will lead us to understand the cumulative risk that we might have given our individual genetic makeup. And I think that is where our success story is coming for the entire country. I'll keep it short. Thanks.
Right. So I think we have a few minutes for a couple of quick questions. I'd really like to give the opportunity to the audience to raise. Yeah, there are a couple of hands up there. So if you could, is there a mic? You'll get to them? Yeah, that would be good. They're at the back there.
Hi, everyone. Thank you for the wonderful talk and all your thoughts. My name is Shreya, and the question I have for the panel is, so you spoke about screening, monitoring, and pharmacogenomic aspect, as well as, the use of genomics and genetics in hereditary diseases. But I want to understand that how do you see the use of liquid biopsy in somatic cancer cases, and what is the future of that in coming 2 to 3 years?
Well, both Joydeep and, I mean, anyone can answer. Please go ahead. Yeah. Joydeep, go ahead. Yeah, maybe, yeah.
So I was just a couple of hours back, I was talking to Joydeep, mentioning that that's going to be a sort of a mini revolution, liquid biopsies in the future. So there are three broad areas where liquid, so basically for benefit of others. So liquid biopsy is taking a blood sample of a cancer patient or even sometimes healthy individual and understanding whether an individual has what kind of tumor, what mutations, what treatment can be given. Is his treatment, if he's already a cancer patient, is effective? Is there a relapse, recurrence happening? So these are all things you can monitor using one single simple blood draw. So this is a new technology that's coming up, not new, but sort of it's been there, but I think it's becoming more and more pervasive across the world. I think developed nations, including US and Europe, are already have firm guidelines on that in all societies everywhere. And we do quite a bit. We do at least about 40 to 50 samples a day on the liquid biopsy. So the three broad segments. The first segment is when you don't have a tissue available. So for example, in 20% or 20 to 25% of non-small cell lung cancer cases, you can't take a biopsy of the lung, okay, because it causes what you call pneumothorax or lung collapses. There are many situations where patient is old or situations where you cannot take a biopsy. So how do you study? So the surrogate is a liquid biopsy. Currently, we call it a surrogate. It could be the primary testing at some point of time.
The idea has been conveyed. I was just wondering if any others would like to add, particularly on early detection of cancers and.
Yeah, I think there's two parts to this, right? So cancer in particular is a disease of changes in the genome. So it's very well suited. When you go to liquid biopsy, there's a specific thing that happens, right? That you start looking for a needle in the haystack. You're looking for very, very small amounts of signal in, that is vanishingly small. And this is where improvements in genomics and improvement in data processing are so important, right? Because you've got to sequence at very high depths. You've got to also, I think, increasingly move towards multi-omic sequencing, right? So GRAIL, for example, which is the leader in what are called multi-cancer early detection tests, they moved from doing a whole genome sequence of every patient to looking at methylation pattern changes, right? And that was the big insight, that you could pick up methylation pattern changes in the blood and start to detect phase 1, phase 2, or stage 1, stage 2 cancers, which are extremely important in changing the survival rates, right? So stage 1, stage 2 cancers have a 5-year survival rate of 80+%. If you detect it in stage 3, stage 4, the same cancers have a 5-year survival rate of less than 20%. So big paradigm shift. Liquid biopsies are key to that. The other thing that we're seeing a big move on is, once you do have cancer, you often, unfortunately, have a relapse. So minimum residual testing or disease monitoring is a big part of this. That's really started to happen in earnest. In fact, the fastest growing market here is on that, rather than the initial detection of the cancers themselves.
Thank you. Can we still take one more question? I'm sorry, maybe give someone else a chance. Yeah, right behind, I think. His hand was raised.
Hello, everyone. Now, I very much agree with what everybody here has spoken about. Now, my question is about the human microbiome project. Right? Nobody, I think, must have mentioned that in genomics. Like, I think that problem has been in my whole academic life. People have been speaking about human genomics for all their time. We are not really focusing on cells which are more than our own cells. Right? We've got more than, I think, 10 times of our own cells as microorganisms. Right? So I would want to know what exactly is the future on that. And more importantly, when do we feel that non-invasive diagnosis could gain more impetus here? Because in general, if I talk about this room, it's a very small sample size, but I, for one, would disagree to any sort of diagnosis if it was invasive in terms of genomics, right? If you just want to find my lineage and just want to take a blood sample for that, I don't think I would be down for that. Like, as an example, in a small sample group, right?
Yeah, so I think we got the sense. Any response on microbiome? Anyone? Yeah, please. Just a quick 30 seconds. Maybe.
Yeah, I can take a quick crack. Yeah. Look, microbiome is, there's definitely efforts going on across the world on that. I think the challenge, of course, is much more data has to be collected before two things, right? One, you can figure out patient to patient or person to person differences and whether certain changes in microbiome. But what you're finding is that these are frustratingly different from human to human, right? The second thing, if anything has to really get broad, adoption, you have to be able to do something with the information, right? Just knowing your microbiome is not enough. You actually have to know, well, what do I change in my diet? What medicine do I change to really then change your microbiome back to a profile where you're healthy? We haven't gotten to that point. So a lot more data needs to be collected. There are efforts going on in several parts of the world, but I think it's still about at least 5 years away. Yeah, please.
I'm not sure if you know or not, there is a similar project like the Genome Project. The Microbiome Project is also sponsored by the DBT. And they currently have some very interesting preliminary findings, but as Dr. Joydeep mentioned, it's too early to think of treatment options. So they do have very nice patterns according to diet and population groups about certain microorganisms being more prevalent than others. And because it is also pertinent about population groups, we might find some unique information from the project, but it's very early to think about treatment options.
Thank you so much. I think we have to stop here. It was a very rich discussion, and we'll make way for the next panel. But I think the organizers have something to say. Yeah, please.
We're going to have the panelists here, so you can always take the questions offline. May I please request Professor Vijay Chandru to give away the mementos to our panelists.
Thank you. So, thank you.
A round of applause, everyone.
Thank you. Praditi, yeah, please come forward there. Thank you. Thanks, Ram.
May I also please request Dr. Rinku, consultant for kids, to please come up on the dais.
One group.
And give the memento to Professor Chandru. Our next session is about smart supply chains in biopharma, which will start at 4 p.m. Thank you.
talking about, smart IT, logistics, supply chains, and where does this come in? How many of you are biotech people? Like you understand biotechnology, you do biotechnology. Okay, thank you very much. So as of 20th March, 2020, India did not have a single producer of diagnostically approved DNTPs. Just simple DNTPs. We didn't have a single company that manufactures DNTPs in this country. We did not have a single company that manufactures RNA extraction kits in this country. We did not have a single manufacturer in this country that makes regulatory approved reverse transcriptase and Taq polymerase in this country. And we've been talking about biotechnology for 35 years. As on day one, when COVID struck us, each of us very happily were paying close to about 5,000 or 5,500 rupees for an RT-PCR test for COVID. We paid 5,000 rupees for an RT-PCR test for COVID. Right now, how much do you pay for an RT-PCR test? Any good guesses for an RT-PCR test right now? 600, you're still paying too much. There are already people offering at 300. So you should search better. 300 rupees. And you think, wow, haven't we really improved? We used to pay 5,000 rupees, we got to 3,000 rupees. No, that's not the improvement story. The real improvement story is the government of India was procuring these tests at a price of 2,200 rupees per test through tenders on day one. You know what is the last price at which the government of India acquired these tests? Right now, government of India, when they put out a tender, how much they are acquiring these for? 12 rupees 50 paisa. Okay. 90% of our tests were imported on day one. Today, 90% of our tests are indigenous. 90% of our tests are indigenous. But it's not just the tests that are indigenous. 90% of the components that went into making these tests were imported. Today, 90% of them are indigenously produced, including primers, probes, DNTPs, RNase inhibitor, UDG, buffers. Everything is indigenously produced today. Today, we are net positive in the sense that India is ready to become the diagnostic supplier to the world. So if we can be the pharma supplier to the world, if we can be the vaccine manufacturer for the world, the idea is we should think, why can't we be diagnostic supplier to the world? It's all about supply chains. When the supply chains got closed, suddenly, the patriotic scientific Indian woke up and made it all himself. But, in terms of supply chains, and that's why we have a very diverse, group here, and I will just share a little with you. If you can just show the first slide so that I can just tell you briefly how we did it. Just, there you go. I could do it myself, I'm sorry. Some help? One slide. One more. One more. That's it. Stop here. This is all that we did. What we said was that in order to create an indigenous, ecosystem, we need to create a core team around Atmanirbhar Diagnostics. We created a core team around Atmanirbhar Diagnostics. We said, if you are a diagnostics manufacturer, if you're a vaccine manufacturer, if you're a pharma manufacturer, your issues, your problems are going to be around chemistry, biologics, quality, clinical validation. How do I scale up? How do I produce 1 million tests a day, right? How do I do fast prototyping? I know all this, but how do I do business? A lot of people were manufacturing that never were in business before. So how do I do business? How do I price this? How do I distribute this? And then every diagnostics company, as both of my speakers here will tell you today, and Mrinalini, who's speaking to you from the US, will tell you today, is that every diagnostics company, every pharma company, every biopharma company needs to be an IT company, an informatics company. Like I'm sure Ravi here will agree, who is kind of telling you about how IT is transforming the world of pharma, biopharma, right? So we took 8 different institutions. We made them centers of excellence. We took problems that the ecosystem was facing, not just startups, the largest of the companies like Tata Medical Diagnostics, Reliance, Syngene, all the way to the startups which just barely had one product. About 210 companies, we created an ecosystem. We took up their problems. We routed them through the centers of excellence. We solved their problems. We gave them solved problems, and we created products out of those solutions. Close to 120 projects completed in the last 2 years. That means 120 different products and solutions out there in the market for diagnostics. Very early on, we realized this is not a solution just for COVID, that this could be applied across all diagnostics. Today, we are indigenization of diagnostics. The informatics platform for this has been provided by TCS to us, and TCS is actually running the market portal for us. You can visit us at ccamp.index and check us out for more information. How do we take the power of informatics, smart IT, right? That is, that Samir here, for example, comes from Accenture, and he provides solutions to some of the largest companies of the world. These solutions to some of the largest companies of the world. I want to hear from Samir today, what kind of problems are people coming to him with, right? In order to solve. That's what we want to hear from Samir. Now, I also want to hear from Ravi, who is probably India's first CIO, and he's the Chief Information Officer, but he's also the Chief of Operations Technologies. So he's just not dealing with the informatics at work, he's also dealing with the operations technologies at one of India's leading integrated contract research, development, manufacturing organization, Anthem Biosciences. From him, we want to hear what kind of problems is he facing and solving on a daily basis himself. We also have Mrinalini with us, who works for Ingram, who is looking at informatics solutions for pharma and biopharma in a global way. But this indigenous principles are very important, because I want Accenture solutions to be available for the smallest of the indigenous players. How do we bring that power to them so that we don't have to look towards China, for all of you should leave this room with this thing. Pregnancy tests, right? So one of the base material for pregnancy tests is a protein that is got from urine. You know that, right? So it's got from it's extracted from urine of pregnant women. It is commonly known. We import urine cakes from China. Okay, so our indigenization travel is very, very, very far away. So without any further delay, I hope I have created enough interest in indigenization and informatics solutions. I will first ask for Mrinalini's talk to be played. Mrinalini leads informatics solutions for life sciences, biopharma, and life at Ingram, and she's in the US right now, but I have a talk from her. Followed by, I want, like I said, Samir to talk a little bit about the kind of problems that people are coming to him that he's helping solve. And then finally, Ravi, a little bit about what he's doing at Anthem in terms of solutions. So first, Mrinalini, please.
Hello and namaste to the honorable guests, dignitaries, fellow industry technology enthusiasts, and evangelists. Thank you for this opportunity, and I'm honored to be a part of the 2022 Bengaluru Technology Summit to present in the biopharma supply chain stream. Apologies that I could not be there in person. And thanks to Mr. Lalit Kishore, Dr. Vijay Chandru, and the organizers for accommodating this video presentation. A few years ago, Prime Minister Modi launched the Digital India Mission. It is great to see this has actualized and proliferated across various sectors of the industry and government. In her article published in the Economic Times on Wiring Up Globalization 4.0, Ms. Kiran Majumdar-Shaw writes about how the pandemic and wars have driven the massive global supply chain disruptions and have revealed the vulnerabilities of these networks. The world needs a digitally distributed supply chain that are future ready and dynamic to meet the rapidly evolving and increasingly volatile customer and consumer needs. They also need to demonstrate the need for commitment to improve environmental, social governance performance by ensuring business operations are circular, net zero, and trusted. This aligns with what Ingram Micro represents in a parallel industry. Ingram Micro is the business behind the world's brands. It helps businesses fully realize the promise of technology by helping to maximize the value of the technology. In addition, Ingram Micro provides IT asset disposal, reverse logistics, and repair services to advance environmental sustainability. We ship 1.5 billion units per year and have an ability to serve 90% of the global population. With over $54.5 billion in net sales, we operate in 61 countries with 170,000 business customers. Ingram Micro supports the circular economy and reverse logistics through our 157 logistics and service centers globally. Ingram Micro has a firm commitment to ESG. In 2021, there has been 8.9% reduction in absolute Scope 1 and 2 greenhouse gas emissions. 86% of our shipping cardboard contains recycled materials, and we increased direct renewable energy procurement by 45%. Ingram Micro celebrates an increase in workforce diversity, equity, and inclusion. Now, let's take a look at how Ingram Micro is addressing the growing needs of the market by the adoption of new and emerging technologies. If challenge is one side of the coin, then the opportunity is the other side. The biggest global impact of COVID-19 pandemic was to the healthcare and biopharma sectors. As these industries rose to the challenge, they saw the opportunity to adopt the technological advancements needed to overcome the hurdles and address a need of the hour. Now, they are continuing to grow above and beyond these limits to continue to keep innovation at the same pace. There are emerging technologies that are being adopted in discrete process and hybrid manufacturing sectors and have high potential to be adopted in biopharma for delivery, efficacy of medication and vaccines. Now, let's get into these specific technologies. Smart manufacturing is emerging to deliver on the promise of Industry 4.0 by adopting automation. It is great to see the advancements in various industries driven by their own market need. IoT in pharmaceutical sector is revolutionizing the industry. It aids pharmaceutical manufacturing, warehousing, packaging, and supply chain by enhancing the quality of product, reducing errors, and increasing productivity. Drugs undergo several clinical trials globally. IoT devices gather the data from the network, transmit it to the integrated software. This real-time access of data helps in quicker identification of adverse reactions and related risks. At the same time, it helps in improving the quality of the test data. Connecting machines monitor abnormal conditions and maintenance. This not only impacts uptime, but also the quality of medicine production. IoT can enable automatic shutoff to correct the quality issues earlier in the production process. Asset tracking to provide real-time view of inventory of materials and also reduce cost of waste. This maintains quality, speed of production, and improved warehousing. Automation of production operations using robots and AGVs to improve repeatability. Quality checks using computer vision to help left shift the quality assurance in the production process. Use of drones in the warehouse to take stock of real-time inventory and provide access to information in real time without walking the floor. Metaverse helps to bring in experts into clean rooms virtually without delays to help speed up the process of production operations. There are many new use cases emerging for digitization of all the industrial processes to provide access to real-time data from the plant floor. Prior to the pandemic, I didn't fully know the meaning of efficacy of vaccines, except for what is there in the dictionary. I surely did not anticipate the value of cold and warm vaccines and how it impacts drug distribution to developing nations and remote parts of the world. As they say, Ando mein ekana raja. Not sure if using this limited knowledge made us experts to determine which pharma company vaccine track we wanted to adopt for our loved ones. It was scary at times. Lots of technologies ranging from disposable LoRa, Wi-Fi, cellular, and Bluetooth-based asset tracking sensors that can monitor location, temperature, moisture, and other environmental conditions periodically from production through supply chain to treatment. Efficacy of these medications and treatments are highly dependent on the maintenance of certain environmental conditions and are less tolerant to deviations from these conditions for short periods of time. These technologies provide store and forward capability to handle loss of connectivity. Pharma industry has a need for reverse logistics for certain medication and treatments that must be safely disposed. We have seen an emergence in innovation with 5G-based drones in India for the last mile drug delivery. And in the next couple of years, drone ambulances delivering critical equipment such as defibrillators to heart attack patients stuck in traffic and telemedicine. All this data is digitally captured, sent to the cloud for real-time tracking, deviation from requirements, and future data insights using AI/ML. During the pandemic, we saw the adoption of AI/ML to track and trace crowd spreader events in the cities daily. There is huge opportunity for pharmaceutical industry to expand the use of AI/ML. The study done by the Swiss Data Science Center has provided some insights into all these different areas as shown in this picture. Computational and algorithmic developments accelerated the domain of drug discovery and development. Biomarker discovery with data science tools that can ensure their sensitivity, robustness, and validate results. Limitation of current medicines, such as incomplete patient history records, limited root cause analysis, and overlapping causal symptoms can be compensated with supervised and unsupervised machine learning approaches. Unsupervised learning can change the way diseases are classified. Harvesting the ability of AI to analyze multiple data sources and types overcome the limitations of manual approach. It is very exciting to observe how AI/ML will be leveraged across the pharma industry in the next few years. During the pandemic, we saw how virtual reality and augmented reality was being used to provide contactless training to onboard and update skills of nurses and emergency workers. The mixed reality technology was used to accelerate research and development of vaccine and medication. This technology brought in global expert remote collaboration in research labs that were challenged by the crippled travel industry. In manufacturing and production, to keep the factories running round the clock, the metaverse technology was used to fix issues with machines as soon as they manifested through remote expert. Unskilled workers executed tasks using extended reality work guides that also provided quality assurance. Interactive ESG safety education was done by adopting virtual reality advancements in gaming technology. Now, extending this to other opportunities. In bio research and development phase of certain drugs, pharma companies can visualize the structure and compositions of their future product. This can significantly reduce the cost of research and time to market for the essential drugs. Extended reality also allows drug production management to be completely automated. This technology allows production factory supervisors and workers in pharmaceutical companies to test new production mechanisms remotely. They can be trained remotely to use the new tools, approve the work accomplished, and provide quality assurance in the end. Augmented reality allows pharmaceutical companies and healthcare experts to use expressive graphics and 3D imageries to show their patients how their health condition is affecting their body and how certain recommended medications will act once it's ingested in them. This technology is just emerging in the space, and more innovations are expected to boost return on investment, productivity, and compliance with regulations. Now that there is a lot of data captured through various technologies, how can biopharma supply chain take the data insights to the next level? You can Google the definition of digital twins. Let's try to demonstrate it very easily with an application we all use in our daily lives, the traffic maps. As I travel around the world, I rely on Google Maps to take me to the right place at the right time. I assume that many of you are addicted to use of this technology too. It takes into account traffic patterns, the roadblocks, the weather conditions, and many other data points. It is truly a digital twin of travel from A to B anywhere in the world. How about if we create a real-time digital twin in the biopharma supply chain? Mapping the entire biopharma supply chain ecosystem in this way is a starting point of real-time all the time supply chain model across all constituents digitally. This digitization of entire end-to-end supply chain means the organizations can see where their inventory is at any point of time in their journey. Companies can even gain visibility into the last miles to ensure that the therapies are delivered and used as prescribed. With the network of digital twins, the risk of duplication of effort can be identified and removed. This extendability is important, especially as it pertains to the ability to build a network of digital twins across key suppliers. Map all the various dependencies relationship in their supply chain and pull everything into a single real-time collaborative supply chain operational source. Digital twins can also be deployed in small scale to meet new challenges related to transitioning expensive specialized therapies from low volume, high value products and services like fertility and cancer treatment products. High volume supply chain operation digital twins can be employed for distribution of vaccines. Digital twins can ensure quality, compliance, assurance, efficacy, and continued on-time delivery. In conclusion, let's remember the goals of the pharmaceutical industry: to promote high standards in innovation, production, and quality assurance of pharmaceutical products. Additionally, to ensure efficacy of the medication to the patient. There are various technologies that are emerging and enabling the ability for pharmaceutical industry to deliver their promise. Thank you for giving me the time to present the opportunities of emerging technology adoption in pharma supply chain. Wishing you the very best and enjoy the rest of the Bengaluru Technology Summit. Thank you and namaste.
Thanks, guys. I know that it was in one chunk. We had 10 questions for her. Okay, so she kind of came out. The key thing is, I just a little bit of a thing, right? I don't know if you're aware, and before I ask Samir to answer this question, right? When you manufacture vaccines have a certain efficacy, right? Or even biosimilars and biotechnology products have a certain efficacy. Specifically, this is a problem with vaccines. So let us say that you're supposed to pack 100 units of vaccine into a vial, right? And this is a problem for Samir, right? You're supposed to pack 100 units of vaccine into a vial. The first thing you do is you go to your production facility, which Ravi will talk about, and you have to be able to confidently measure 100 units of vaccine, right? Now, the problem in the vaccine industry is the best measurement quantitation techniques for vaccine have a coefficient of variation of about 25%, which means that if you want to measure 100 units, you can get 75 units, you can even take 125 units. So what do? Oh my God, what if I have only 75 units? So you actually overload your vial. Thoda zyada dalte hai is vial mein. Okay, let us put a few little extra so that even if it is by mistake 75, I'll minimum have 100. But does the story end there? It doesn't end there. From there, where does it go? It goes into the warehouse in your company. If you don't store it properly, the efficacy keeps dripping down. Then from there, where does it go? It goes to a central stockist. From there, it goes to a local distributor. From there, it goes to your medical supplier or a shop. And in the shop, in the refrigerator, it waits for a prescription to arrive at the front desk of the shop. Till that time, there is another 50% depletion. The company knows about this. So what do? I know I'm supposed to put 100, but my measurement system could be giving me only 75. So I will put more. But then, my warehouse, a little loss will happen, little more. Stockist, little more. Medical shop, little more. So finally, your vaccine overload in most cases in India, even for the cheapest vaccines, it doesn't matter. Polio vaccine costs what? 3 paisa or 4 paisa per dose. So if you put 50% extra, kya jata hai? But if you have niche vaccines, where if you have to overload this 50%, 60% each time because of supply chain issues, because of storage issues, because of issues that can be sorted out without any major changes in technology, then imagine the extra productivity you will get just by being more efficient, Samir. That's the kind of problems that Samir faces. And anyway, Samir, what kind of problems are people coming to you with? What kind of problems is Accenture solving?
First of all, I mean, all the, the talk that that was given by the earlier basically speaker seems like they have solved for all, and I think that's a great thing. If they have done it, nothing like it, right? But I'm not going to talk about global because India typically, when it comes to digital, fact of the matter is till 2018, till 2019, in fact, digital was just basically a theoretical exercise in various different organizations, right? No one wanted to talk digital. Everyone wanted to talk about, I don't want, because of the socio-economic factors. I mean, no one wanted to really dabble too much into automation or technologies or IoTs. So I think 2020, as you rightly said, things changed. And suddenly India, which was a laggard, has taken steep jumps into this particular domain. Now, specifically talking about, the pharmaceutical industry, I think we have to see, before talking about the technologies, let's understand what are the challenges that they're facing. Number one challenge, there is a slowdown. There is a market volatility that is happening in US and in Europe or in the Western world. Number two, 71% of the drugs that are there in the market globally are facing degrowth, right? Which means there is enough and more pressure on the new drugs coming into the market. So so the speed to market of the new drug has become that much more important. Which means that now the organization is dealing with multiple different SKUs. Impact of all these things is number one, the cost has gone up. Number two, the service levels have dropped. Number three, there is a significant impact on inventory. Your inventory levels have gone up, which is impacting your EBITDA, right? Now, this is the burning platform that the Indian pharmaceutical major is really facing. So now, to address this particular challenges, there is only one way. You've got to actually, you have to have an astrological map in your hand. If I can predict all the disruption, if I can predict all the problems that there are in the world, I will be able to manufacture it in a much more efficient manner. And the answer to it is basically digitizing your supply chain. The future is autonomous supply chain, and I will talk about it in a bit. But the answer to all the problem that our pharmaceutical friends are facing is digitizing their supply chain so that it is more intelligent, it is more data-driven, and the supply chain professionals are taking a more informed decisions in their day-to-day activities, right? I will talk about the autonomous supply chain, but let me pass it on to my friend Ravi to talk about what has been his experience.
All of you, can you hear me? Yeah, a little louder. Yeah, can you hear me now? Yeah. How many of you are aware about there is a drug which is used for COVID therapy, not a vaccine. There is a drug which was very popular during pandemic 1 and 2, remdesivir, right? So let me give you a small brief. Proud to sorry. Can, hello. Yeah. We manufactured a key excipient which is used in the remdesivir. So most of you are aware that there is a pharma companies in Hyderabad which manufactured and supplied, right? So we are the behind the entire process. We developed it and we innovated and we supplied a key excipient which is treating much better for the patients, like an efficacy or whatever you call docking score. So we contributed for that particular drug. Being a CDMO, when the innovator approached in 2020, April 4th, they want to do remote audit. So we were the first company to get a remote audit in India, 2020. The kind of infrastructure we built by anticipating kind of disruptions. So we built this kind of remote, concepts from 2009, over a period of time, helped us significantly to achieve the remote audit. Most of you, how many of you are aware that if you want to launch a new product, you have to undergo several regulatory, approvals. It's not easy to make a product overnight, and even the customers, they can't approve the vendors overnight. There is a process which is established, and they need to follow. So 2020, April 4th, none of the Indian pharma company thought that we will be undergoing a remote audits. So that is the time where we, said yes, and we completed on April 4th, and May we were able to produce the batches and supply to the large pharma companies in India as well as abroad. And pandemic taught us a lot of, lessons. For example, we used to believe 4I principles, right? Today also we have a 4I principle. 4I means two eyes, operator is performing it, 2 eyes, supervisor supervising it and acknowledging the job. Today, by using technology, you can avoid 4I principle. You do that job, technology let us identify the events and address to the quality assurance. That's the biggest challenge, right? Today, we are not able to digitize in the most of the manufacturing. You're talking about smart supply chain. How do you enable the smart supply chain? Unless until your manufacturing and quality and laboratory is integrated, then only it can become a smart supply chain. Today, most of the pharma companies are looking at the outer periphery. The dosage criteria is above 60 and then 45 above and then 18. There's a shortage of vaccines, right, those days, because the manufacturing facilities are designed to produce a certain type of products. That's another challenge, right? Today, people are talking about flexible manufacturing. So we anticipated. My role is to bring the technology, and as Vijay said, I'm leading the IT as well as operation technology. Both are different verticals, right? South and north side, right? So IT is conventional IT, but OT is also again conventional in pharmaceutical. So my role, uh, you know, my expectation, I mean, we expect to bring IT OT together and make a more efficient smart factory kind of a thing. Today, we brought flexible manufacturing. We don't need to depend on large capabilities. If you have to build a large capabilities, it takes 2 years. Can drug can wait for 2 years? Like for example, your remdesivir, your COVID vaccine, can it wait for 2 years? And how many of you are aware that any drug to release a new drug to the market, how many years it takes typically before COVID vaccine? How many of you are aware? Any guess?
8 years is my
8 years, 5 years, 10, 15 years. Today, COVID vaccine is available in 12 months. It means that there is an R&D, there is a regulatory approvals, there is a manufacturing, there is entire, system is integrated, right? I can share my personal experience. When I was hospitalized, they want to give me remdesivir in the pandemic too. Okay, I said no. I am very well because I joined, I admitted in hospital to support my wife, and my oxygen levels are 97, 98. I don't want remdesivir because we are manufacturing remdesivir. We know, when to use remdesivir. I said no, even though I'm a techno guy. I said no. The same vial was kept on the doctor's table for 48 hours. Imagine, most of you would are aware, right? Remdesivir can be stored outside 4 hours only. It need 2 to 8 degrees temperature. Now imagine after 48 hours, what is the efficacy? What is the drugs, capabilities,
You
right?
probably got water for injectables.
Now, if the
After
same
that.
drug is given to the patient, imagine, right? So that's a knowledge level which we are carrying. And there are a lot of people who could have heard, right? Counterfeit drugs today, especially remdesivir, there's too much of shortage. Why? We don't have a smart supply chain. We don't have pharma, hospitals, who's the end customer for pharma? Hospitals or patients, right? So we don't have an integration. That's another challenge. So we don't have demand coming from hospitals or areas, right? That's another challenge.
So what next, Samir? What because we have probably about 10 minutes to kind of get
Wrap
to
it
the
up,
end.
yeah.
But
Yeah.
what next? What's the next big thing?
See, the next big thing is definitely the impact of metaverse on supply chain, but we are not there as yet, right? I think we have to first start walking before we start running, and I think as Ravi basically mentioned, I think the idea is getting the journey starts with, of course, you need to have a foundational clean ERP in place with a clean data, right? And data in today's world in Accenture, or sorry, in a lot of our clients is anything but seen, right? So the journey starts with a clean data. Of course, then it needs to be, he's talked about understanding where the demand is coming in from. So which means that you need to identify the micro markets. Because I'll lead retail as well. I can tell you in the retail, the concept is the segment of one. But in pharmaceutical, we need to understand the micro markets, which will give you a good hand on the demand. Hence, you will be able to do a good supply planning. And then, hence, a great SNOP planning, right? But SNOP does not stand. India's problem is execution. Then that SNOP needs to get integrated with SNOE, which is Sales and Operations Execution Plan. So this is the first, I would say, the building block, if I can say, that one needs to really have. After you have that, then it is about how do I make it autonomous, which means how do I use AI, how do I use ML technologies to take a lot of decisions that the supply chain planner takes to ensure that it is autonomous on the fly. If we know that data, some crappy data is coming into the system, how does an AL algorithm can basically pick it up and tell the planner, alert the planner saying that This data is not complete. Let's complete it, right? So that is where the thing is going to move towards autonomous, supply chain in India. And once we have conquered that space, let's talk about metaverse. So I think, but there is a journey. I mean, supply chain has to be looked at as a journey. It is not, you get some injection, apply some tool, and suddenly you become intelligent supply chain. The world is far away from the reality. The reality is getting the foundations correct.
Ravi, one big challenge that you want to solve in the next 12 months. What is that big challenge that you want to look at, that you want to take up as a manufacturer?
Yeah, today biggest challenge in any pharmaceutical company, real-time batch releases. How many of are aware that there is a batch which is produced in a biopharmaceutical, a biological kind of thing, or vaccine? How long it will take to release the batch by quality assurance? Any guess? How many days? 60 days?
60 days.
It is too much. Like, the patient is dying another side.
2 months.
You are manufactured, but you're taking 60 days to release the product to the market. So we actually partnered with multiple vendors and we are developing an ecosystem. We want to release the batch real time. Means the production is completed, the testing is completed. Why QA has to wait for 2 months to get the batch to be released it? Or 1 month. We want to release the drug as soon as it's produced it. It means that you need to integrate your order to dispatch cycles. There are a lot of things happens, right? You get an order as a CDMO, you place an order with vendors, track the materials, manufacture it, and test it, and release the product. It has to reach to the customer place for formulation.
Real time is important. And thank God that we are in a stage today where we can kind of, if not laugh, at least smile about the pandemic days. Because today, imagine if it takes 2 months to release your batch of vaccine, one of the first things that will happen is that there will be a variant.
Yeah, another variant.
Before you release this vaccine, there will be a variant. So obviously, speed is important. I know that topics are interesting, but I want to bring this to a close by saying that vaccines, biosimilars, recombinant proteins, pharma, of course, is one thing. When you get to genetic medicine, cell and regenerative medicine, the very concept of a factory is changing. The very concept of a factory is changing. How do you kind of evolve into a situation where you're ready for that kind of a world if you're not ready for this one yet? Ravi, you wanted to add?
Yeah, so the new technologies are emerging, right? You could have heard personalized medicine. Today we are taking a medicine, we are not sure whether it is suitable to our genetic, right?
Yeah.
Or cell gene therapies are coming.
Yes.
So cell gene therapies life cycle is very, very short time. Like, you collect the patient sample, you process it, manufacture it, and infuse it into the patient again,
Yes.
right? Thus, you need to respond within 4-5 days. The whole cycle, hospital, manufacturer, test it, and put it back to the patient. The whole cycle is 4 to 5 days. Now, how can you
exactly
collaborate it? Hospital, pharmaceutical, and patient need a collaboration. Today, the technology is very expensive.
The raw material supplier is actually the patient here. So how do you verify the the quality of the raw material?
And the slot
And
availability.
then again, the recipient is the patient, because going back into the patient, how do you do that? All within 4 days. The concept of a factory is changing. And how do you adapt to that level of, and then where does supply chain come in there? So where is the innovator? Where is the manufacturer? He has these hubs and spokes where he's doing this. So every little place becomes a manufacturing facility now.
Absolutely, and hence, when we call about intelligent organizations, any one operations lead such as Ravi, they need to be sitting in their office and be able to monitor what is really happening.
Across the board.
And it is possible. But it just what is missing, or not missing, that's a wrong word. I think what it requires is more intent.
I think so.
To really get there.
Since most of you are talking about smart supply chain, I can give an example. We built a smart factory, the first smart factory in India, where thousands of equipments and integrated. I have a large display control room which monitors. During pandemic, suddenly March 2024, my team is disappeared. The young team who works in, because I head the other side also, right? Process automation and instrumentation. Most of this team sits in the shop floor. There was overnight, the lockdown announced, we don't have team members actually. So me and my other colleague were able to manage the entire infrastructure. We asked my team and production QA, be at your place and connect remotely and monitor. So we could able to achieve the monitoring of the entire warehouses, materials, production processes, because we can't shut down it. If you have to shut down, it would be a planned shutdown, or if I have to restart it, and it takes maybe 60 days, 90 days to produce again the life cycle, right? So most of the drugs you see in the today market might need to start production 180 days before, or 120 days, or some of them are 1 year back, or some of them are 60 days. So we have to produce continuously. There is we used to face tremendous pressure. I used to be in the shop floor, right? So today we have technology which is available to monitor remotely and get the real-time insights. What are the quality events? And we helped our quality assurance team to identify the events remotely and take actions and release the drugs overnight. That kind of automation we brought in, and we want to improvise it further. And we are working with a lot of partners to digitize the whole journey. Tomorrow our customers might ask, right, can I see my process where exactly it's manufacturing? What are the quality events? Tomorrow regulatory can ask, today regulatory is inspecting your facility once in 2 years and approving the facility. Tomorrow it can be real time. Where is the batch produced? What are the events? Can you share the events? So we are getting into that kind of a space.
Absolutely. Any concluding statement?
Yeah, so, and I was thinking about it, Lalit. What will be my parting thoughts for this evening? I think, when the world is talking about metaverse, and we talked about, basically IoTs and digitization of supply chain and autonomous supply chain. Tomorrow, when you go to your work in your own function that you're really working on, my parting thought would be, think about data. What is that data that is going to help you take the right decision in your day-to-day activity, right? Once you start thinking about the data, the rest will all follow, because everything can be available in a jiffy, in a real-time basis. The rest is basically all technologies that will enable you to get that data.
This is the real example. In pharmaceutical, you get a lot of unstructured data, and you create a data lake, and you don't know what to do with this data because it's not structured. So people are talking now data lakes. Now future is going to be data fabric, unified systems. Go for unified systems. If you are from pharma, try to get an unified system and do complete end-to-end cycle in a 1 or 2 systems, rather than having hundreds of systems and struggling with the data, right? That's another challenge which pharmaceutical companies faces today.
Thanks, Ravi. Thanks, Samir. I hope it was of use to you. If you have any questions for them, because we've reached the very end, they will be here. You can ask them. Thank you so much. I'll take one question because you have a question. Yes.
Hello, everyone. I'm Mustafa Sharif from Orphocus Healthcare. So my question to Ravi sir. So what was your reaction when sales of Remdesivir were going high? How did you handle pressure with your team and in organization? Are you happy when the sales was going up, or you were worried because of the supply chain?
Both.
Yeah, it definitely, I can share one, real-time example. I used to tell my fellow colleagues, we need to be very careful. This drug might be used by ourselves. It becomes eventually true. My family members, most of my colleagues are used remdesivir, right? So this is a reality. So we cannot be very, on a lighter note. When the demand is too much, we were also trying to exploit the supply chains. There's a lot of disruption. Okay, we were dependent on other countries to get some of the raw materials. And now today, we made 80 to 90% of our inputs are Indianized, like means domestic. We developed a supplier ecosystem. We have identified 30 to 40 suppliers across India. We have ensured that we are not dependent on XYZ and other this side, right? Second, there was a tremendous, pressure. You need to do it, right? So we were actually doing a lot of R&D and flexible manufacturing. our thought process and flexible manufacturing. Somehow we were able to quickly dismantle the existing equipments, bring into our own control system and start producing it, a key excipient which is used in remdesivir. We were able to meet 30 tons, 40 tons, whereas we were actually were thinking about 4 tons, 10 tons. So we scaled up quickly in a week's time, 4 to 5 times. So did I answer your question?
Yes. I just want to conclude by saying one thing. When my son was born and when we were giving him vaccines, and doctor gave me two choices. One of them was Pfizer and one of them was a Indian company. I said, no, whatever it is, I'm in biotech and all that. But when it comes to my son, you know what? Give him the Pfizer vaccine. Let's move on. Right? But when it came to COVID time, I was confident about choosing an Indian vaccine, and every single time I'm confident about choosing an Indian diagnostic kit. That's the change that's happening, guys. Thank you very much.
So thank you very much for the most insightful session. May I please request Mr. Lalit Kishore to please give away the mementos to our speakers. I request Dr. Rinku, consultant kits, to please come up on the dais and give away the memento to Mr. Lalit. Yes, so the panelists will be available to take the questions online in case you want to connect to them. One quick photo sessions. Our third session for the day is about gene editing in agriculture, which will be at 5 o'clock. Thank you, sir. So good evening once again. Our next session is about gene editing and agriculture. We have here Dr. K.K. Narayanan, Director and CEO, Strika Seeds Private Limited, and he's the moderator for the day. I would request Dr. K.K. Narayanan to please come up on the dais and take over the stage. Thank you.
Good afternoon, friends. Can you encourage some of the people who are standing outside to come in so that we can start the session? Guys, come, please be on the stage. You made it. Okay, here also. Is there a tea session or something outside? Okay. Somebody can go and request them to come inside. Can we start the session? Okay, some of you at the back, do you mind coming forward, please? Thank you. Please. So good afternoon to all of you once again. I am Narayanan, the moderator of the session. This is on gene editing in agriculture. Now, I'm sure most of you are aware that gene editing has come of age in the last 10 years or so, last decade. Tomorrow I think morning, there's going to be a talk by Professor Emmanuel Charpentier, one of the co-discoverers of various aspects which actually went into the CRISPR-Cas9 gene editing technology, which is now almost routine in many labs today. And we have this session structured in such a way that we'll have two talks of approximately 20 minutes each, and then we will have a question and answer session. Some quick thoughts on gene editing. You must all be aware that this is a powerful technology, not just in animals, but also in crop plants. It is increasingly being applied for introducing various traits. So here you're not introducing a new gene. It's not transgenesis, but essentially modifying the genetic makeup by changing one or two base pairs of the DNA. And very recently, about a few months back, the government of India has notified the guidelines for regulating these crops. You don't have to go through the really onerous steps that are needed for getting out or commercializing a GM crop, which involves a much grosser genetic change. Most of, at least two types of gene editing technologies, the SD1 and SD2, which involve very minimal changes in the genomes, either addition or deletion of a few nucleotide bases, can go through like development of any other crops through breeding. A few years testing, and it's pretty certain that if it passes the test, you can get them out. There's no further assessment or roadblocks. Gene editing also has come into the commercial arena now. The first gene-edited crop to be commercialized is a tomato variety called Rouge, Sicilian Rouge. That's the name of the variety, commercialized by a company called Sana Tech in Japan. And very interesting work, tomato accumulates a compound called GABA, gamma aminobutyric acid, which has got a lot of health benefits, including moderating the blood pressure. Now, the genes that are in the pathway for producing the GABA has a domain which actually leads to self-limitation of the production of GABA as the fruit matures. Now, these researchers have very cleverly edited some nucleotide bases in that domain, thereby switching off the self-limiting mechanism so that it continues to accumulate GABA. So this is just one example of an ingenious application of gene editing technology for producing crops which are improved for useful traits. Now, there are many such traits that can be improved, and a lot of work is going on in India in several labs in the public sector as well as in the private sector. And you might have read any issue of Nature Biotechnology. Nature is necessarily should have one paper on some aspects of gene editing. To discuss the various aspects, we have two eminent speakers today. The first is going to be Dr. Brad Ringisen. He is the executive director of the Innovative Genome Institute, which is an institute founded by Jennifer Doudna, one of the co-discoverers of the various aspects which went into the CRISPR-Cas9 technology, and a Nobel laureate along with Emmanuel Charpentier. And he is basically a physical chemist with a PhD from the University of Wisconsin-Madison. And the institute was started in the University of California, Berkeley campus. And he has held various positions, both as a researcher as well as a research manager, and is eminently suited to talk on this aspect. So he comes to us through a recorded presentation, which was recorded sometime earlier. He couldn't be here. So we will first start with the recorded presentation of Dr. Brad Ringisen, who is the executive director of the Innovative Genomics Institute. So we'll go through about 20-25 minutes of his presentation. Then we take the second presentation, and I hope that we will have about 10 minutes for interaction at the end of the session. Brad Ringisen, for you, please.
Hello, my name is Dr. Brad Ringisen. I'm the executive director for the Innovative Genomics Institute at the University of California, Berkeley. And I'd like to thank the organizers today for the opportunity to speak about gene editing and CRISPR and the opportunity it presents for sustainable agriculture and climate change. So I'll share my screen here to start my presentation. But I'm going to be talking today about CRISPR and agriculture, and how to feed the world while combating climate change. And I'd like to first just introduce what the Innovative Genomics Institute is all about. We are an institute with cutting-edge science in genome editing and genetic manipulations, but we do so with a social purpose. We were founded in 2014 by Nobel laureate Jennifer Doudna, who discovered CRISPR genome editing. And our mission is to bridge this genome editing tool and the development and enhancement and improvement of that tool to affordable and accessible solutions in human health, in climate, and in agriculture. And there's a wonderful quote here from Jennifer, our founder, and we collaborate very, very closely with her now still. We have a responsibility to pursue CRISPR's enormous potential to achieve previously impossible solutions to some of the world's biggest challenges, solutions that will be available to anyone. So that's really the social purpose. Can we use this tool and this amazing new technology to help people's lives across the world? How do we do that? Well, we do it by collaborating. And you can see here on the right-hand side of this slide, some of the seeds that have been edited by CRISPR and the power that this new tool is able to do. But what we are at the IGI really is a place to allow people to collaborate across different universities, even across international boundaries, because there's so much potential of this technology that we can't do it all ourselves. So it's a technology that can apply to all living systems. It can be human cells, it can be plant cells, it can be bacteria and microbes. And we at the IGI are able to deliver gene editing and genetic modifications and characterization across all of those systems. So what do? We try to improve genome editing technology. We use CRISPR to screen and find new genomic targets in human systems and in plant systems and in microbes. And we also look at ways to deliver CRISPR into those cells or into the systems that are needed. That could be a crop, that could be the human body. And then finally, I'm going to talk to you at the end of my presentation about some new work that Jennifer and her collaborators are doing in the microbiome. And there's an enormous potential in both the human microbiome, but also in the plant and soil microbiome to be able to help support sustainable agriculture and applications in climate change as well. So here is the Innovative Genomics Institute. This is our building here on the campus at UC Berkeley. And we have about 48 principal investigators. We've started a big entrepreneurial program where we support startups and those young faculty that are young faculty or young postdocs or graduate students that would like to try to start companies. We also have 6 research centers, and obviously we publish a tremendous number of publications. And you can just look at a snapshot of some of our philanthropic donations that we've raised over just the past year or so. We are about 80 or 90% philanthropically supported. So we're constantly looking for opportunities, for new donors, for partnerships, to be able to strengthen those asks to the community to be able to support the amazing groundbreaking research that we do. Here is our leadership. We see Jennifer Doudna, our founder and president, myself as the executive director, and the dean of biology at UC Berkeley, Mike Botchin, as our deputy director. But we also have world-leading scientists and doctors and MDs in human health, and those advancing those emerging genome editing tools, people like Jill Banfield and Ross Wilson, as well as those that focus on sustainable agriculture and climate, like Brian Statskowitz. But we also do all of this with social purpose. And our director of public impact, Melinda Kliegman, is really in charge of looking at the communities that our technology advancements might affect. How do those communities, are those patient populations? Are those farmers in low and middle income countries? Are those the regulatory bodies here in the United States, like the FDA or the USDA, to look at the regulatory aspects of what we're developing from both, not just the technology development, but also from how the path to get to global impact. What is that path and what are those steps for us to be able to take? Here's our strategy for the Institute. As you can see, the core root of what we do is really in genomic technology development, with people like Jennifer herself, as well as Jill Banfield. These are the world leaders in developing genomic technology, genomic innovations and genomic technologies. We're going to continue that historic innovation and discovery. But we want to do it in a way that we're looking at applications and the translation of those discoveries to impact the world. And we do this in 2 primary areas. We do it in climate and sustainable agriculture, what I'll be talking about today, where we're looking at engineering scalable green tech solutions using plants and crops and microbes. But we also have an entire component of our institute that looks at human health and looking at trying to make CRISPR an accessible new technology to be able to become the standard of medical care for all genetic disease. We then push on to do field trials. Right now, our partners at the UC Davis, which is right up the road from UC Berkeley, and then this organization called CGIAR, which is an international organization that helps bring new technologies to farmers through seeds and distributing those crops to those that need it. And then on the health side, we work with universities, medical schools here in California for clinical trials. And then we see public impact sort of grounding all of this work, where we look at accessible and equitable and community-guided solutions. That can be a community of farmers in low and middle income countries, or it could be communities of patients here in the United States or potentially in other parts of the world. So we really look at taking our innovation from basic research to applied research to translation. And we look for partners and collaboration on every one of the steps of that process. So let's look at our climate and sustainable agriculture program and look at the reason why we're looking at CRISPR and gene editing, because there's big problems in the world right now. By 2050, the Earth will become home to around almost 10 billion people. And we think that genome engineering can help feed that growing population by engineering crops of the future that are resilient against climate change, that are sustainable and provide the nutrition that those people will need. We also think we can enhance disease resistance. As the climate changes, you're seeing more and more diseases that are attacking crops throughout the world. We think we can create and generate plants that are immune to that infection. And then finally, we think we can develop new methods to efficiently deliver CRISPR to those crops, to be able to bring this to all the scientists and engineers around the world to be able to help distribute and really be able to help expand and scale this technology. I don't know if you know, but agriculture globally is responsible for about 25% of the greenhouse gas emissions. So even if we went to an entire electric economy, if we went to green energy generation for that electric power, we would still have a significant greenhouse gas emission problem globally. So we think that plants and microbes in agriculture can actually be part of this solution, not part of the problem. We think we can engineer microbes and crops to help reduce greenhouse gas emissions through genome engineering of agricultural crops and soil microbes. And we also think we can increase the long-term carbon capture and sequestration in soils, on farm soils. And I'll talk more about that in a little bit as well. So here is how we do this right now in the Innovative Genomics Institute. We go from discovery, where we're looking at new technology and new genomic targets. We then go on to validation, where we take the lead targets and the lead technologies, and we try to move them from the lab bench to the field. And then ultimately, we would like to translate those technologies through partnerships to begin field trials and look at the farmers and work with the farmers to be able to uptake those technologies, to be able to disperse them throughout the world. So some of those discovery technologies, we're looking at new ways to engineer and edit crops. We're looking at new ways to deliver these technologies to plant cells and to crops. And then we're looking at different ways to identify targets for many different applications, like the resistance to disease, the maybe photosynthesis to be able to enhance yields, or ways to be able to increase the nutrition of crops. We're also looking at high throughput ways where we maybe don't have to grow up an entire plant to determine whether we've been successful in editing that crop. And so we're looking at ways to be able to very much more quickly innovate from a discovery in a laboratory to be able to show that it actually works and that we get the edit and we get the sort of the phenotype of the crop that we would like. And then finally, we've also innovated in what's called genome-resolved metagenomics. This is a way to not just look at a library of microorganisms in a complex environment like soil, but we can actually look at the genetic and genomic profiles of those microbes to be able to find exactly the microbe that might be able to fix nitrogen, or to be able to capture carbon or fix carbon as well. So, and then in terms of developing from the bench to the field, we take things from the laboratory to the greenhouse. We're looking at ways of putting multiple genes and stack them together to be able to have multiple traits and phenotypes in one crop species. And then we're looking at ways to be able to scale up that technology so that it isn't just staying in the laboratory. And then finally, and this might be an opportunity to partner with India and farmers and scientists in India, would be to look at field trials and ways to be able to look at specific crops of interest or agricultural processes in India to see if we would have the opportunity to be able to partner with universities or with farmers in country. What applications? Where do we think we can have impact by using these technologies? And this is an amazing slide that shows the potential impact all the way from restoring soil health. So if there are marginal lands that maybe don't have as much fertility. Can we use these technologies to be able to increase the amount of carbon and the amount of nitrogen and phosphorus in those soils that are available for crops to build those soils back up? Can we reduce what farmers have to use to be able to generate yields and increase yields or protect their crops from a changing climate? Those pests that are emerging, the water shortages and droughts, potentially salinity and salinity tolerance, and the disease resistance and tolerance as well. And then we want to do this not by sacrificing yields of those crops, but actually enhancing the yields to be able to maximize both the yield and calories of that crop, but also the nutrition that's involved in generating those crops as well. And then if we look at the other side of the slide, we also want to try to reduce agricultural emissions from crops that are really have a lot of nitrous oxide and methane emissions like rice, but also animal emissions like cattle and livestock. And we think that this technology of gene editing can work with soil microbes as well as with microbes that are in the guts of livestock that are the organisms that actually are responsible for generating that methane or nitrous oxide. And we think that we can actually work with those microbes to be able to increase productivity of the cow or of the livestock and reduce the emissions of these dangerous greenhouse gases back into the environment. So how do we manipulate plants? And it's been a long thousands of years of humans manipulating plants, all the way from the initial way of doing it for selective breeding that's slow and only works within species, to now in the early 1900s doing mutation breeding, but it's relatively random and unpredictable. And then moving on in the 80s to really make a big leap that is sort of the advent of modern agriculture with transgenic breeding. But this has random insertions of genes, and it also inserts foreign genes. And then in the 2000s, really is what the future is going to be, which is genome editing, which provides precise, fast, and really leaves no genetic trace, a DNA trace of the technology changes and modifications of the crop. So that's really the advancements that we're talking about today, is really with something like CRISPR-Cas that can target specific genes, that doesn't leave DNA behind in the plant. And what you're seeing from a global aspect, even over the last 2 years, you're seeing a significant shift in the Americas, in Africa, and in Asia, and also in India, where you're now seeing these crops that have been modified using CRISPR not being counted as genetically modified organisms. And there's a thumbs up, to be able to green light the development and advancement and regulatory approval of these crops. So now is the time to really accelerate the discovery and innovation and really real world impact of this technology on a global scale. What is some of the breakthroughs that have happened at the Innovative Genomic Institute? We have a plant and genomics transformation facility that's able to actually develop methods of using CRISPR edits in 25 crops, including wheat and rice and cacao. And we really have real world impact. We have a recent crop of cassava that we've edited out the cyanide production in that crop. And then also through global partnerships to really be able to do international field trials of these technologies. And just as an example, here is some transformed wheat crops that we've shown, where the red fluorescence is evidence that we've created a genetic manipulation from those in about 4 to 7 weeks. And you really can go in about 6 to 8 weeks from a non-edited crop all the way to an edited crop for an important staple crop like wheat. And here is also cacao, which is tremendously difficult to genetically manipulate, but our plant transformation facility has now successfully generated a plant of cacao that's actually resistant to the swollen shoot virus that's endangering and threatening cacao. And then I mentioned the cassava experiments that we've done as well. This is showing, again, the transformation process of cassava. And we've actually now taken out the gene that produces the cyanide, which is builds up and it's toxic for many farmers, especially women farmers in places like Africa. Here are some of the featured projects that are going on at the Innovative Genomics Institute. We're really trying to carve a pathway to a net zero farm. And one of those ways of doing that is to try to really make a climate tolerant crop. And we're really, really proud of the fact that Brian Staskowitz, our Director of Sustainable Agriculture, has now used CRISPR to alter a promoter of a gene in rice that allows a range of drought tolerance. And so the graph on the bottom here is showing if you tweak and tune that promoter, then you're actually able to change and alter the amount of water that's needed to grow that rice crop. And so if you want drought tolerance, you can actually engineer this crop to be able to work with less water. So for those areas that are drought prone, then you're able to actually do that. And so this has succeeded in our greenhouses, and we're now field testing this in Colombia in South America. Professor Jill Banfield has now looked at a rice field in California and has performed and generated the most deeply sequenced rice paddy microbiome to date. Tremendous amount of opportunity here, not only to reduce methane, but also to increase yields, to increase the nitrogen fixation and the loss of nitrous oxide to the atmosphere. A huge opportunity here. She's looked at the populations of microbes in these in that system, looked at not only the microbes, but also the genes that are involved and the regulation and expression of those genes, and also the trace gas emissions simultaneously at the same time. And this is really going to unlock a lot of potential to look for targets for reducing methane, reducing nitrous oxide, increasing the carbon content of those soils, and increasing the nitrogen content of those soils as well. And then finally, I know that there's an important crop in India, and that's the banana. And I think we're really at the cutting edge of being able to edit and modify bananas to be able to engineer in resistance to the Fusarium tropical race 4 that's threatening the Cavendish species of banana throughout the entire globe now. And Professor Staskowitz and Myung-Jae Kim at the IGI have developed a high throughput genome transformation method to be able to edit and really tune and tweak the banana to be able to insert not just 1 or 2 or 3 resistance mechanisms, but potentially create something that has 7 or 8 different resistance mechanisms to Fusarium tropical race 4 to be able to eliminate this threat, not just now, but well into the future as well. And this is something that's very, very exciting that's going on inside of our crop. And here I show a picture of one of those edited Cavendish species in our laboratory right now. And how do we now bring some of these innovations to the real world? And we do this through a memorandum of understanding that we signed with the CGIAR. They have 15 research centers throughout the world in 108 countries, and really they distribute germplasms throughout the entire world. And they have 50 years of experience doing this, but they came to us and said, we need your genomic innovations to be able to help feed the world and to do it in a sustainable way. And so we're really going to be partnering over and over again. Our first one is the drought tolerant rice that's going to be at a CIAT center in Colombia. But we're going to do this over and over again with using CGIAR as our partner to be able to do this. Now, I want to also feature a couple really big new projects that are occurring at the Innovative Genomics Institute. And one of them is accelerating biological carbon capture and storage in agricultural soils. And this is really an exciting, large, multidisciplinary, multi-institutional program that's been started at the IGI. And we're looking not just at the soil, not just at crops and how those crops store and use carbon, but we're also looking at the photosynthesis mechanisms that remove atmospheric carbon from the soil, from the atmosphere as well. And so I don't know if you know, but from the advent of modern day agriculture, agricultural soils have lost almost 500 gigatons of carbon dioxide equivalents. And the question that we're asking is, can we now put that carbon back in those soils? And you can see the heat map. India is one of those large areas. The United States is also one of those large areas that have lost a lot of carbon. Some of this is just from runoff and erosion, but a lot of it is the fact that modern agriculture essentially strips carbon out of these soils. And so much of those carbons are now depleted, soils are depleted of carbon, and we want to be able to use gene editing to be able to help put that carbon back. That's going to increase the fertility of those soils, increase the yields of those crops, and potentially take marginal lands that maybe don't have very high yields, and over time turn them into more fertile soils that then generate higher and higher yields. So we're looking at engineering rice plants initially, because rice is so genetically tractable that we really think that that's a great way to be able to demonstrate improvements quickly, to be able to identify target genes that can enhance photosynthesis, generate enhanced photosynthesis up to maybe 30 or 40% higher yields and higher efficiencies of photosynthesis. Then looking at our second step, looking at the carbon flow in those plants to be able to not just increase biomass and yields, but also pump more carbon underground in deeper roots, and also in the carbon that flows out of those roots that feeds the microbiome in the soil. And that's the third step, is looking at that microbiome, trying to pump carbon deeper and deeper into the soil to be able to increase the fertility of that soil, but also the longer, promoting some of the mechanisms that promote longer carbon times and residence times in that soil. And we do that by looking at the interactions between the plant and the roots and the soil microbes, and what mechanisms of those microbes promote longer and longer carbon storage and making that carbon bioavailable back for the plant as well. And then finally, I want to talk a little bit about the microbiome. And I'm not sure if people are that familiar with the fact that the microbiome plays an enormous role in human-caused emissions for agriculture. And the chart here on the left shows the impact that those microorganisms have in agriculture. Clearly, with livestock and manure, those emissions that are coming from livestock are based on the microbes that are in the gut of those cattle. And they produce methane, but at the same time as they're producing methane, they actually reduce the efficiency of the feed efficiency of those cattle. And so if we're able to stop the methane productions using editing to shut off some of those mechanisms or turn on some of the mechanisms that could capture some of that methane, we could actually reduce methane and increase the yields and productivity of those livestock. And then also landfills and wastewater, and as well as agricultural soils associated with rice cultivation, and those agricultural soils also result in emissions. And so we think that there's an opportunity here to use these microbiomes rather than just allowing the emissions of greenhouse gases back into the atmosphere. Can we work with gene editing like CRISPR to be able to help modify those microbiomes and the microbes that are involved in these processes to be able to help capture some of these emissions rather than releasing them into the atmosphere? And so we think we have a potential solution. And Jennifer Doudna and Jill Banfield published an article late in 2020, late in 2022, that shows an emerging tool set for using CRISPR-Cas to help engineer and modify microbial communities. They've taken CRISPR and have actually shown in a complex microbial community to be able to go in and modify, directly target microbes, regardless of whether you can culture and modify those microbes in the laboratory. You can actually take them and do this directly in a complex microbial community. And we think that there's a lot of potential to look at all of these different systems, whether it's a landfill, whether it's wastewater, whether it's rice cultivation, to be able to look at ways to be able to shut down those greenhouse gas emissions, microbially generated greenhouse gas emissions, and really go in and potentially make modifications that would not really be considered dangerous in any way, shape, or form. We've already talked with the regulatory bodies in the United States, and if we're going into microbial systems, you can actually engineer a lot of different safety mechanisms into those systems And the USDA has already said, look, we see a very robust and very fast path to be able to get approval of these modifications, because microbes are constantly sharing genetic data and making genetic modifications on their own. So they see a very robust path to be able to get approval for these types of modifications. So we really see between crop modifications and now microbe modifications, we see a really bright future on ways to be able to help feed the world, to do this in a sustainable way, and really be able to open up new doors to not only feed a growing population, do it in a nutritious and a very responsible, sustainable way. And so we're really excited about the future. And I just want to end by thanking you all for the opportunity to speak today. Sorry I'm not there to be able to give the presentation in person. If you want to learn more about the Innovative Genomics Institute, it's a very easy website, innovativegenomics.org. We're on Twitter, we're on Facebook, we're on LinkedIn. And if you would like to contact me directly, my email is bringeisen, that's BRINGEISEN @berkeley.edu. And again, I thank you so much for giving me the opportunity to speak with you today. And I hope the best for a successful conference. And I very much enjoyed speaking with you today. Thanks a lot.
Please put your hands together for Brad, even though he could not be here. I think we should be grateful that he shared his presentation and his thoughts. So that was a broad overview about the organization of IGI, as well as some details about the projects they are pursuing. Some of them, I think, are of good relevance to a country like ours. And we can discuss it offline. But let's quickly move on to the next presenter and presentation, Professor C.S. Prakash. He's currently the Dean of the College of Arts and Sciences at Tuskegee University. My old friend, I have known him for a long time as a great researcher, plant biotech researcher. He worked on sweet potato for a long time, did some seminal discoveries. He has been a science administrator, a leader, and I must say that he has been a great communicator promoting responsible science. And what's not given in some of the books or literature that you're having is that he just is coming from Dubai. He was there yesterday to receive a prize on one of the top influencers of food influencers using communication systems. One of the 3 recipients of that award given by the American Soybean Association in their meeting in Dubai. So without much further ado, let me leave the stage for Dr. Prakash.
Thank you very much, Dr. Narayanan, and thank you for inviting me to speak at the Bangalore Tech Summit. I'm really honored to be here and talk about gene editing. And we heard from the previous speaker, and I'm going to continue to make some very specific examples along the lines of what was presented, and to see how that could be of relevance to Indian agriculture. And so, as a plant breeder and geneticist, I always remind our audience that when they ask me why do I have to keep modifying our crop plants, and we tell that the history of human civilization started with the modification of plants and livestock. You see, we took wild plants around us, like the banana that you see, or the maize that you see around in the bottom there, and we changed it. And so we have continued to change our crop plants for using a variety of tools. As we saw in the previous, did I press something wrong here? Yeah, I may have accidentally pressed the end button. Okay, I'm sorry about that. So we have been using a variety of tools, and as we heard, we have been using selective modification. We've been using mutagenesis, using radiation and chemicals, and in the past 30 years, we have been using GM crops, and we know BT cotton is one great example where it has made a tremendous impact, grown by about 6 million farmers here in India. And As we move on, the more recent technique is gene editing, which essentially involves just tweaking the genetic architecture within the system without necessarily introducing a foreign gene. And that is why it is of considerable interest, because it overcomes some of the limitations that we had with the GM crops, primarily due to the regulatory burden that it imposes. But nevertheless, what gene editing uses is the tremendous knowledge, the explosion in the knowledge we have due to various omics. The genomics consider related gene in our ability to understand the gene, and we heard in some of the lectures and presentations before us, the transcriptomics, the proteomics, the metabolomics. So we have a revolution underway in where we are having an unprecedented access to the biology of our crop plants. And what the gene editing and some of the tools helps us is to leverage that knowledge and see how we can bring about some of those changes using the CRISPR-Cas and a variety of other gene editing tools that we see here to bring crop cultivars, to develop improved variety of crop cultivars using this. But we also, that has aided the genomic selection using marker-aided selection and QTL mapping, GWS. In other words, gene editing is just one of the tools that the genomics is helping us move forward. But in many ways, the crop breeding, the crop improvement is revolutionized by a variety of tools. And so I just wanted to provide with some of the examples here. Let's see, I'm maybe pointing it in the wrong direction here. Can you move into the next slide, please? Yeah.
Can we move to the next slide?
I'm sorry about that. So you can see when there is a technology, there's always technology can go wrong. So anyway, what I wanted to show was some of the few examples of gene editing, as we heard from the previous speaker. One of the most important applications of that is in helping improve the disease resistance. Here you can see in tomato, where by editing certain genes, they were able to improve for powdery mildew resistance. And at the top is the susceptible control varieties and the gene edited in the bottom. And if you go into the next slide, you will see a similar that was done in the previous speaker talked about, is a genome editing of banana for wilt disease resistance. And on the right side, you see the control variety because of the wilt, and on the left, you see the gene edited one. On the next slide, you will see a similar work for citrus cankers resistance, where you can see on the left panel, the gene edited varieties are free relatively of the canker and compared to the control on the right. The next slide would show a similar research for the bacterial speck resistance in tomato. The next slide show rice. Rice blast is a very important disease in India, along with bacterial blight. These are the two of the important diseases for which a much fungicide is used to control this disease. And again, you can see an example where gene editing, by tweaking some of the genes related to the susceptibility, they were able to develop a resistant variety of rice. The next slide, please. And this is a research from India, which has just recently been announced and fully not published yet, from Indian Institute of Rice Research in Hyderabad, where they are able to, using gene editing technology, take a very popular variety of rice, Samba Masuri, and by altering a specific loci, they were able to increase the yield by about 35%. And again, as you can see, with the control and the gene edited, a very remarkable improvement in the yield of the rice. And this is, again, a very graphic illustration of the application of gene editing. The next slide would show if you could, where we could also, by altering the number of genes related to the grain size in wheat, the scientists were able to increase the grain size of the wheat. And this is again an illustration to show that the genome in editing technology is not necessarily limited to the single loci, but also in quantitative loci. It could be altered to bring about change in the polygenic traits, such as yield. The next slide. Yeah, if you keep going a couple of times, which as you can see, the increasing the number of genes, we can increase the seed size. And similarly, genome editing is also of value in increasing the plant architecture. And this is a very fundamental point in the plant breeding, because in the Green Revolution was predicated on changing the architecture of the wheat, making into a dwarf wheat, and again in rice also into the dwarf rice. And so a lot of our crop varieties tend to be perennial and also creepers. If you look at our aurekai, for instance, the traditional varieties tend to be very long, and even the cotton. And making into a dwarf, if you hit a couple of times to change the slide, will show you that by single gene changes, by gene editing, we can make plants change, improve the architecture, thereby improving the productivity of the plant. The next slide would also show how we can use this for improving the nutrient efficiency, primarily to, when you recognize about 80% of our fertilizer use is wasted in the farm. By improving the nutrient use efficiency, we can improve the fertilizer, the nutrient uptake, thereby reducing the fertilizer usage in the farm. The next slide would show that for the nutritional improvement, this again, the left panel was a research done in India, where they were able to improve the availability of vitamin A in banana. And on the right, a University of California research showing a golden rice, again, a very pro-vitamin A rich rice that was earlier developed using maize genes, using GM technology, can also be achieved similarly with the gene editing technology. The next slide would talk about how we can do the increase in nutritional content, this with lycopene content in tomato. The next slide would show the example that Dr. Narayanan talked about, the GABA, high GABA tomato that has already been released in Japan. The next slide would show a gene editing technology to achieve slow ripening. And when you recognize 50% of our fruits and vegetables in India are lost due to the rotting and the ripening, the delayed ripening that we can bring about in all our climatic fruits and vegetables is going to improve improve the quality of the produce and increase the shelf life of all of fruits and vegetables that we grow here in this country. The next slide will show again an example of how they were able to develop a diabetes-friendly rice by improving the grain quality, by making starch, by altering the ratio of amylose and amylopectin, and making starch more resistant to digestion in a way that could be making a low glycemic rice. The next slide would show a similar research that was done in potato. When you cut the potato, you will see within few hours it will start browning, right? And there's a major wastage in potato because of the browning. And just by altering those polyphenol-related genes, they were able to reduce this browning in potato. The next slide would show an improved beer by altering the barley genes. And the next slide would show some of the more important research that's going on in trying to deal with the climate change and how we can reduce abiotic stress related to drought, waterlogging, the flooding that we have recently seen here in Bangalore and in Pakistan and many other places, the heat and the salinity. The next slide would show you how specifically for drought tolerance, there are a variety of mechanisms control the drought. And again, using CRISPR-Cas, we have scientists are able to make some really remarkable improvement. The next slide would show one example of drought tolerance just to improve the root system. And as you can see on the right side, a gene-edited Arabidopsis showing a very vastly improved root network. The next slide would show a similar genome editing in tomato for temperature tolerance. And as you know, one of the global climate change impact is going to be the increased temperature. We already seen here in the last couple of years. And again, trying to develop crops with temperature tolerance is going to be an important thing. The next slide would show a drought-tolerant maize developed in Africa. The next slide. For flooding tolerance in maize by discovery of sub-1 gene. And increasingly, this was been achieved using really marker-assisted selection. And again, gene editing would make it help develop some of these varieties faster. The next slide would show a similar research being done to improve salt tolerance in tomato. Next slide. So one other approach is we already have many of our native crops that are very climate resilient. A lot of our millets, our root and tuber crops, like ragi, and many of them. So, but they are not as productive. And many of even our older varieties, like when I was a child, we used to eat Coimbatore Sanna, is the type of rice. But we don't grow that anymore because it's not as productive. But by using gene editing, we can bring back many of these older varieties and also make our millets and others more productive. The next slide will show also we can take even the wild ancestors of our crops, like the Lycophysinum peruvianum on the left shown here, by altering those wild varieties, and we can make them a domesticated varieties, but keep some of the resilience traits in the wild germplasm. The next slide will show a broad overview of everything, and I'll just pass that and go to the next slide. And I've already shown this. The next slide would show the variety of means that which CRISPR-Cas is being used not only in deleting genes, but also in altering the gene expression, the epigenome modification, gene activation, and many, many different possibilities with this system. The next slide was just an overview of all the things that could be achieved with gene editing. And the next slide would essentially show what the previous speaker showed about the importance of regulation, and that India is very fortunate that we have a very streamlined regulation for genome editing that makes it possible even smaller institutions, the universities, and small startup companies to bring products into the market, unlike GM crops, which was primarily in the control of a few major multinational corporations. The next slide, which will simply show a new book that was co-edited by me and others, where many of this information is available. So I just thank you again for this opportunity and look forward to the questions.
Thank you very much, Sir Prakash. I think we saw an overview of what's happening in Innovative Genomes Institute, and now an overview of what can happen or what can be the outcomes of the genome editing technology when applied to crop plants from Dr. C.S. Prakash. If I can seek your indulgence, I think can we take about 10 minutes for a couple of questions? Is that okay with all of you? Okay, I think whoever has a pressing question can raise their hands, identify themselves, and direct it to. Brad is not here, so it can be to Professor Prakash, or it can be to me as well. Yes. Can you provide the mic to her?
Hello, sir. Good evening. I'm Iron. This might be a very simple question, but with gene editing and all the varied works that are going on in agriculture, doesn't it put an abrupt stop to natural selection process? And is there any chance these genetically modified or the gene edited plants can become invasive in the near future? because their productivity is much higher and people prefer that. We can say that India was fully in green, like when it comes to these plants, because the productivity and the demand is so high. So is there any chance these plants can become invasive and totally wipe out our native species?
Right. Thank you very much. That's an excellent question. And this is something that is in the back of every plant breeding program that one does, is to see how to ensure that the plants we breed by any mechanism, whether it's conventional breeding, mutagenesis, or transgenics, or GM, or gene editing, there's always a potential risk that some of the crops that we develop can become invasive. But historically, only in a couple of instances that has been possible, primarily because the germplasm that we use are the crop varieties that are so far removed from the wild that many of them would not survive in the wild without the care that we do in agriculture. So even if we alter some of the traits, that the chance that they would become invasive is very, very less. But the risk is not zero. It does exist, and that is why we have that regulatory mechanisms where we ask those kinds of questions, especially with GM crops, with almost all the GM crops that have been approved today, including cotton in India, was to ensure that they do not become invasive. Again, the answer to that, the comforting answer to that is that the risk of that becoming is so small that it is not as much a concern as some of the other issues related to crop improvement. Thank you very much. It's a good question.
Let me add, I think, to what Professor Prakash said. Genome editing should not be considered as a silver bullet. Let us be very clear about it. So I think the thought that it is going to replace every other technology, conventional breeding, selection, it's not going to do that. In fact, the problems in agriculture are so many and so diverse that we need a plethora of technologies to address them. And even if you do gene editing, you have to go through a breeding process to introgress that trait into whatever is required. But I think one thing we need to keep in mind, anything that we do, even sitting in this room, under this roof, is not without any risk. There is risk for anything, but we have to weigh the risk against the benefits that are offered. And we have to make a rational decision on whether the benefits far outweigh the risk or whether the risks are significant and real. For fear of imaginary risk, we should not actually hold back technologies which can give real benefits. Thank you. Yes, Professor Chandru.
Just very quickly, what is the actual status of the regulatory position on gene editing?
Okay.
In India, I think.
Good. Since I was involved with formulating that or giving my suggestions, can I, Professor
Go ahead, please, yes.
Okay. I think in 2019, there was a white paper put out by the Department of Biotechnology. It was a discussion paper on some of the aspects of gene editing and their regulatory oversight, what it should be, a proposal. So we all gave inputs for it, and inputs were called for from industry, from scientists, from activists, from everybody. And at the end of the day, I think I am very happy to say that about a few months ago, 3-4 months ago, the government of India actually notified it as the official guidelines for gene-edited crops. So gene-edited crops can be classified into 3 categories: site-directed nuclease 1, SDN1, SDN2, and SDN3. SDN1 and SDN2 category of gene-edited crops involve one or a few base pair changes. Right. It is changing the native sequence. It is not introduction of a new sequence. SDN3 can be a larger change, so that gets classified as regulation under the normal GMO or transgenic type. whereas SGN1 and SGN2 can get commercialized once you prove its safety and efficacy over a 2-year period of testing. So the regulatory path is clear. If there are any adverse symptoms found within this period, I think they will not get commercialized. But agriculture in this country is a concurrent subject, which means it is part of the union government's responsibility as well as the state government's responsibility. Any crop, whether it is gene edited or normally developed varieties through breeding, conventional breeding, has to go through a regulatory process of testing. Now, once you get the safety clearance, it is up to the states to allow you to sell that variety based on the performance in that ecosystem. So there is a two-tier system, and whereas now the central government will essentially look at the safety aspects of it, and the state governments, if I as a company want to sell a gene-edited crop which has been cleared for safety purposes in a state, I have to put it through trials, multi-locational trials, including in the public institutions like universities, to prove that it is performing the way I claim it to perform. So that's the system now.
Thank you.
You want anything to add?
No, not really. You have much familiarity with the system.
Okay.
But again, this what India does is in line with about 20, 30 other countries who have a similar streamlined regulatory system, which is much lighter and less burdensome than the very long and protracted and very expensive regulatory system for GM crops. As you know, India has not really approved any GM crops other than cotton, and only recently now
the mustard.
With the mustard, so only 2 of them. And so there was a 20-year lag between the cotton and the mustard. And so hopefully...
So people are realized that, and then now slowly, I was mentioning it in another meeting, that there's been a slow opening up. Some of the trials which were stalled earlier are now restarting. Right. Yes, you had a question. Sir, 1 second, sir. I will give it to him first, and then yours will be the last question.
Thank you, Dr. Narayanan and Dr. Prakash as well. So my name is Suraj. I'm from Ankur Capital. We are an early stage venture capital firm from India. Very interested in the space of agri biotechnology. So my question basically comes from from a startup perspective. Development of an advanced seed variety is still a long process, right? I mean, it takes a few years. So what are you seeing in terms of the innovations that's happening, from the startup lens or across the world? What are you seeing in terms of either reducing the time span for, seed discovery or anything else that you're seeing in this front?
You want to go first?
Yes, I'll go very quickly, but you have greater familiarity with that process, and so you can. Yes, I even with GM crops, still the trait, the discovery, the validation, and the regulatory process, was stretched around 8 to 10 years. And now with gene editing, there's still the vetting and the testing process would still exist, but the trait discovery and the regulatory has been reduced. And so hopefully, from 10 years from lead to marketing, it's probably would reduce to 5 or 6 years, I would say. And again, I know that's for many of the startups, this is a very attractive path to follow.
It's also attractive because there's been some technological interventions which allow you to fast track the generation time, because breeding is essentially taking it through multiple generations. So there's what is called speed breeding, they call it, by manipulating the light conditions, the photoperiod conditions, and the temperatures. You are able to take 3 or 4 generations in a space where you used to take 1 or 2 generations. So that is becoming more and more popular in many crops. There are many institutions in India as well, which are putting up speed breeding facilities, including ICRISAT, IARI, and some of the private institutions are also investing in those. So those can be fast tracking the time taken for developing varieties or stabilizing the varieties.
That's correct. And also one other area where really it has helped in the crop improvement is in the genomic assisted selection, marker assisted breeding. now the technology is moving so rapidly that we are able to identify many of the traits and predict many of the traits just based on its the gene sequence information without having to necessarily grow the plant fully through the whole season, which
That's
is
true.
also helping in fast tracking crop improvement.
That's
Are you,
true. I hope it answers your question,
Yeah,
right?
just a follow up. Are you seeing anything on the lines of the AI ML side where you're basically having a lot of this information data coming in, and some level of prediction analysis in terms of, okay, if there are these 1,000 varieties that you come up with, the model actually tells you, choose the best sort of these, and then work with those.
Exactly. That's an excellent question. Yes.
Right.
And this is an area where, we talked about the genomics and proteomics and everything, but it's the area that I did not mention where the artificial intelligence and machine learning has the greatest impact is in phenomics, where now crop improvement is a very cumbersome process of literally dealing with hundreds of thousands of plants and growing them and then evaluating them, measuring them, weighing them. All of that has now made it easier with the improvement in phenomics, because by using sensors and many other technologies, we are able to measure faster, identify some of the best performing lines very quickly. And that is very rapidly developing. I would see in the next few years that's going to really impact the crop improvement process. In a
Many
remarkable
institutions, it's almost becoming routine to use computation and other technologies to data crunch and mine the data. I think that's important.
manner. Right.
Can we have the last question?
Yeah, I'm Ashok Mehta from Krishi Kalpa Foundation here. Thanks to Ankur, I think the question was same. I was trying to push the kind of startups initiatives here. I think the R&D is one aspect, another is commercialization. Like in most of the illustrations you give, presentation, you can do the bit of prioritization where the startups could focus right away and see there could be some inroads, maybe taking the Indian context and start doing it. And the foundations here from which we can support these initiatives.
Thank you.
Yeah.
Any last word, Professor Prakash?
Well, India is the 5th largest economy in the world today, and in my lifetime, we have seen India grow. It's leaps and bounds in so many different areas. India exported $25 billion worth of agricultural products last year, and India is number 1 and number 2 in so many different crops and products of agriculture today. India is already, in many ways, the office of the world. India is the technology provider, and India can also be a grocer and a food provider of the world, because we have at our disposal many of these innovations, and if we use it in a meaningful manner, and I think we can feed India, but feed also the rest of the world with the knowledge and the resources and the bountiful land and other factors in our favor here.
Yeah, with that thought, I think I will draw this session to a close, and I hand over this microphone to the organizers.
A big round of applause for all of us. So thank you very much, sir, for a very insightful session. May I please request Dr. Vijay Chandru, sir, to please come up on the dais and give the mementos. Dr. Rinku, please come. Photo session. So with this, we come to the end of today's seminar on biotech leading the new normal. We will have the Silver Jubilee function, which is only by invitation, followed by the felicitation ceremony. Thank you all and have a nice evening.